to work. Is the resolution good enough? It seems a bit.
Yeah, I think it's good.
Cool. So, yeah, hello everybody.
Thanks for coming.
Yeah, welcome to this Ethereum JS workshop. I'm Gabriel from the Ethereum JS team.
My name is Scotty, also from the Ethereum JS team.
Yeah. So today we're just going to be walking you through our monorepo called, the Ethereum JS monorepo. So we're basically the JavaScript team of the Ethereum Foundation. And what we do with the Ethereum JS monorepo, let me actually bring up the slides. It's going to be helpful. So yeah, what we do with Ethereum JS is we basically build a set of tools that people can build upon. So we're used by lots of, JavaScript tooling that I'm sure you're familiar with. And and it's really a great set of tools for people to learn about blockchain in general, because JavaScript is a really easy to use language that a lot of web developers are familiar with. And we're focused on, helping out a lot with research as well. I mean, we have, for example, a client going, but it's not a production-ready client like Get and others. And that's kind of an advantage for us because we can jump in early for, newer EIPs and implement stuff because we're not constrained by the maintenance of like a production-ready client, for example. So, yeah, we've been helping out with lots of, newer EIPs. So, yeah, that's just, an example of that. So, yeah, 3 of the latest PRs that are in progress in the monorepo are, a stateless Virgil state manager to help out with Virgil trees that Guillaume and a bunch of other people are working with. EIP 4844, which I'm sure you've heard about, like proto-danksharding EIP. And, beacon chain withdrawals, which are going to be part of the Shanghai hard fork. Hopefully, I think the community would be pretty mad if that doesn't get in. So, yeah, you want to take it?
Sure. I'd also like to just say hello and maybe get a sense of who's with us today. If people used our monorepo yet, are you dApp developers? Just get a sample from the crowd of what brings you guys to this workshop? Anybody?
Raise your hand if you've already interacted with the Ethereum JS monorepo.
Okay. Cool. So this is relatively new to most of you.
Awesome.
And that's good. It's part of our focus is having these tools available in a language that devs know and are building in. And as you're learning more about Ethereum and about how all this works, hopefully our library can help you get there. So yeah, I've been with the team since the beginning of the year. Gabriel's been here a little bit longer, and
yeah. So I'm going to go through that slide quickly just to give you a sense of the kinds of packages that we have. So we have an implementation in TypeScript. I mean, we're called Ethereum JavaScript, but technically, right at the moment, everything is TypeScript. We've migrated to TypeScript about 2 years ago. So we have a TypeScript implementation of the Ethereum virtual machine. We also provide, building blocks like transaction, blockchain. We also have a bunch of smaller scope utils. Like for example, if you want a RLP, recursive land prefixing, encode things, decode things. We have a TypeScript implementation of a Merkle-Petruccia tree as well, which is, the data structure that Ethereum uses. We have a dev P2P package and an experimental client. It has synced mainnet. There's been a guy who was able to sync mainnet up to the tip of the chain. It's not really performant, so I mean you wouldn't want to use it in production, and we don't have the mitigation that are in place for more production-ready clients. But it is able to run all blocks from mainnet. So yeah, I was just mentioning it's used by a bunch of tooling. So all these are some of the packages that I'm sure you're familiar with, like Hardhat, Truffle, MetaMask, Remix, Web3.js, and a bunch of other projects use us as a dependency to build upon. So yeah, let us give you an overview of how the Ethereum JS packages kind of work together, right? So at the very bottom, we have the client. Now the arrows pointing to the client mean that the client is importing, the packages, all these other, packages. So at the very bottom, we have client, which imports basically everything that we've built in the monorepo, whereas common is just going to be more like general things that you probably wouldn't use by themselves, but are going to be helpful for, like, for example, in common, you would have like specifications for hard forks and stuff like that, which if you want to, build a block, you need to know like which hard fork you're building, a block for. Same thing with a transaction. Same thing if you want to run a block in the EVM and stuff like that. So that all lives in common. We've tried to modularize it in a way that makes more sense and that makes it easy to import and export things without them being all intertwined. So yeah, you might have heard like the term VM, EVM, EEI. We also have a state manager. So basically, VM is like a higher level, like virtual machine, which sends. You would provide that like a block. You would tell the VM, hey, I want you to run a block, or I want you to run a transaction. Then it would forward an individual like message calls to the EVM, which would deal with like the opcodes and all that sort of stuff. Then the EVM would report back and communicate with a state manager that's going to update like whatever state you have in your Merkle partition tree. So it's much easier to interact with the state manager because then you can just, for example, update an account's balance rather than like finding the proper key in the Merkle partition tree, updating that, and recomputing the root, which would be super tedious, obviously. So we've abstracted most of that away with the state manager. Yeah, I'll leave you to Scotty to talk about the portal network, which is another thing that we are working on.
Right, portal network. It's actually a series of networks that are peer-to-peer networks, special storage networks, and this is all under construction and under design at the moment, but we are implementing portal network clients in TypeScript using Ethereum JS libraries. There are 2 other teams working in Rust and Nim at the same time to implement this. So essentially, if you want to interact with the blockchain right now, you either need to run your own full node, which is a very heavy process requiring a lot of your resources, and most people aren't going to do that, and most devices aren't going to want to do that. So most reach out to Infura, which is a centralized access to the blockchain, which works fine, but it is a centralized access to the blockchain, which is kind of the thing we're trying to avoid. So people have been working for many years trying to figure out what goes up in that top left box where we can have something lightweight, accessible, but also decentralized. And the work on LES-like clients has eventually led us to this concept called the portal network. Portal network is it's an independent peer-to-peer network. It's almost like a BitTorrent. It's working on that principle where if you need access to some amount of information from the blockchain, you don't need to actually sync to the entire blockchain to retrieve your block history or your account history or many of the things that human-driven wallet interactions need. So that's the idea. We're building networks to support the users of this protocol, not necessarily building up the protocol itself the way a real full node does. And therefore, this can exist on very light resource-constrained devices. You could build it into the back end of a wallet app, and it can just be running in the background of your phone or your watch or your anything. And essentially, the more devices hooked into these networks, the better they will work. And part of that is that you don't have to sync to the entire blockchain, because that takes a long time and doesn't really make sense for a small app or a small device to want to do that. It takes a long time, it's very heavy, and doesn't really get you where you wanted to go. So with the Portal network, you could just reach out, get the tip of the chain, get your account balance and all these things, and be immediately serve your purpose. Just kind of explaining the same thing. With Infura, everyone's reaching out to the same thing. With the LES, you get this kind of pile up where the more nodes involved in the system, the more clunky it works and the harder it is to actually return anything. But a distributed system, everybody's got a little piece of responsibility of the network, and they hold as much data as they're willing to, and they serve as much as they can or want to. So for a practical example, in just a JSON RPC call for ETH get balance, right now, if you're running a node, you have to maintain all of these databases where you can look up the canonical index, you can look up storage, you can look up state, and return these things, calculate them, and then return the balance. Portal network's going to work exactly the same, but instead of looking into your own databases, your own huge piles of state and history, you can reach out to these light networks. You can receive your balance, receive history, receive state, and send it and return it in the exact same way. So for the user using a JSON RPC call, it feels exactly the same, but it is possible with very, very limited resources. And ours is called Ultralight. There's two other teams. One's called Trin. They're working in they're Rust, and a client called Fluffy that is working in NIM. So the cool thing about ours is that we have a CLI client, but we also have it working in a browser. So we can open up a browser page to, we built like a stupid, just a small block explorer, but you open up your browser page to this thing, and the browser itself becomes a Portal client using the same kind of memory and storage as anything else, and can both look up and serve. Yeah, what else am I saying? Yeah, essentially your app can be a Portal client if you were to bake it into your app. It can basically just be running in the background. You don't even really have to think about it, but it's distributing the data among a large network of pockets and phones and laptops. Essentially taking a lot of the load off of full clients and making a lot of this data available in a much more lightweight way. We have been building the history network for the last year or so, and that is imminently operational. And then the idea is that the other networks can just build upon that, but they will be independent networks. So as a Portal client, you can participate in one or all of them. You can be there as a freeloader and not contribute anything, and it really doesn't take much away from it. If you think about, BitTorrent, most people don't really go into their torrent apps and change a lot of configurations to be selfish about it. Most people just download the thing and use it as it comes. And essentially, you don't even really have to know that it's happening, but you are serving the entire network yourself. So that's a side project, but it's very exciting and is definitely part of the future of how these things will work. Yes, sir. So it's a distributed hash table, both of content and user addresses. So for the most part, you're going to be randomly assigned an address in that sphere, and you can sort of configure the radius of data you're willing to be responsible for. Yeah. So you would be a peer on the network. If you constrained yourself to only holding like a tiny bit of data, then you're not going to be asked for it very often. There are certainly malicious ways to, put a bunch of nodes up that aren't doing anything, but I don't know. It just kind of means that we've built something worth attacking, first of all, and that there are solutions to those problems that can be worked out. And just, I think we're counting on the just general laziness of users that are going to download a wallet app that somebody made and not necessarily configure it to be like weirdly malicious. There's no incentives here. It's all just there because it benefits users, and by benefiting one user, you benefit all users. So yes, there are ways to attack it. There are ways to be mean about it, but I think for the most part, as long as enough users are just kind of passively participating, then that's not as. This isn't crucial to the protocol itself. Like Portal Network going down does not affect Ethereum in any way. So we can build this thing that's lightweight and hopefully just working on like natural law essentially. Nobody really has anything to gain by trying to shut it down, and it doesn't really affect anything. Problems that we're working out. We're trying to steam ahead with like building the thing and then like solve all of these problems along the way. But yeah, please. It's Ultralight team is just 2 people. It's me and Andrew from our team. So we're always looking for help or for whatever kind of contributions are out there.
Yeah, cool. Other questions on that before we move back to more like the actual Ethereum.js mono repo? Yeah.
So we have a concept of a bridge node, which is something that is synced to the net and is synced to the chain and is just feeding into the Portal network. If we have enough of those, it just kind of saturates over time. We also have just kind of ideas of how to, I don't know, maybe like a babysitter node that kind of like circles the network and looks for gaps and kind of helps fill in the gaps. But yeah, it's these kind of bridge nodes that originally saturate the network and maybe maintain that. Mm-hmm. The boot nodes are, we have DevOps just put up a bunch of nodes for us that are acting like boot nodes. There's no real difference between a bridge client and a just regular client. It's more, are you doing this extra work to like add to the network, or are you just helping to gossip around the network?
All right, so we'll move ahead with a demo of Ethereum.js. So as you know, the next hard fork is going to be named Shanghai. And there's a testnet running at the moment. It was down for a couple of days, but it got back up, I think, this morning or last night. It's a testnet that basically implements a subset of the EIPs that are going to be part of Shanghai. So there might be additional ones. The one on this list at the moment, but the like tentative like list of the IPs that are going to be included at the moment is the one you see on the screen. So the beacon chain withdrawals and the deactivate self-destruct aren't implemented yet in our client. But yeah, the Shandong testnet is up and running. We have it running with Lodestar as a consensus client, which is like the TypeScript, consensus client. And then we have it with Ethereum.js as the execution client. So that testnet it's live. You can look it up. There's a block explorer that I think we just put up this morning. And as far as I know, like the only execution client that's actually running that at the moment is Ethereum.js, so the JavaScript client. So what I'll do is just I will not access like the actual, live testnet, but I'll run like the testnet locally to give you a sense of how you would go about doing that. And you might be interested in running that yourself when we go into the more like interactive part of the workshop. So I just need to check out the proper pull request from our mono repo. So it's just that here. So yeah, as we said, our mono repo is broken into packages. Can you see the VS Code? Yeah, cool. Awesome. So we'll just go to the package client. And I have a couple of instructions I've done here. So basically what we first want to do is we want to create data folders for both the execution layer data and the consensus data. Yeah. Zoom in. I'm not sure if I can zoom in Notion, actually, but I can definitely zoom in VS Code. So at least it's going to be that. Is that better? Yeah, cool. No worries. Oh, yeah. Yeah, they're actually available on that pull request. And in a couple slides, there's a link tree with all of these outlined. So you definitely can access all of these nodes. And yeah, it's a good exercise as well to run that yourself. You will have time for that, and we'll be happy to help everyone get that running. So yeah, the first thing we want to do is just create some data folders where the state of the where the consensus client data and the execution client is going to live. So we're going to put that in data. Yeah, Shandong. So we're going to create an Ethereum folder, and we're going to create a Lodestar folder as well. So now we're good to go for that part. So the next step is we're already going to start our execution layer client. And it's going to use Genesis that's been done by one of the guys on our team. Usually like Shandong at genesis.json. You'll see that more clearly like here.
You're in packages.
What?
You're in packages.
Oh, yeah. You're right. Thanks. Yeah, and there we go. Hopefully that works. Live coding is always a bit sketchy. The Wi-Fi is pretty good, actually. If you haven't noticed, there's a workshop-specific Wi-Fi network that you can access because the global Wi-Fi isn't working that well. So yeah, we see that we have a JSON RPC server started because we started our client with the RPC engine flag. We have a Genesis that we've specified, and the data directory is Ethereum.js, which we've just created. So that's pretty fairly simple. So by default, when you run the Ethereum.js client, it's going to consider that the merge hard fork has been activated because we've specified a Genesis after that. So at the moment, it's just waiting for a consensus layer client connection. Without that, it's going to be not going to be able to obviously execute blocks because it's not getting any. So this is exactly what we're going to do. We're going to start the Lodestar consensus client. So the first thing we need to do is we're going to need to specify the Genesis hash to the consensus layer client. So to do that, I'm actually going to bring up Infura, and we're just going to query the hash of the. I'm not going to bring up Infura actually. I'm just going to query the local RPC that we've seen specified here. You see somewhere up here. Start JSON RPC server, localhost 8545. So I'm just going to do, this is just a tooling to like visualize, requests a bit better. So let's see if I can recall how to do that by heart. We'll see. So we're just going to send a standard like JSON RPC request to get the data of the, the very first block in that, execution client state. So method then is going to be, what is it? It's eat get block by number. And if you see me make a typo, be sure to point it out so that we don't break our execution layer client by sending him like bad stuff. And so we're just going to specify, the very first block we could specify earliest as well. This second option is just if we want the transactions, we'll say yes, but it doesn't really matter all that much. Then we need to specify an ID, I think. We'll just go with one. Can you see properly? Yeah, cool, big enough. So let's see if that works. Cool, yeah. So we've got, the first Genesis block. We should expect like the parent hash is going to be 0. This is post merge. So the mixed hash is 0. It's unused. The nonce is 1, 2, 3, 4. Not sure what that is, but that is probably like a default value or something. So we're just going to take the hash, and yeah, we're just going to copy and paste that. So then the only other thing that we need is we need to specify like an initial like timestamp. So I'm just going to quickly get the timestamp like in seconds, and we're going to add like a few like seconds to that when we do that, right after. So I'm going to start the consensus client here, and this is a fairly, long command. It's running with Docker. Like I've already installed Lodestar in my machine. I didn't want to do that, here, but we can help you, set that up later if that's what you want to do. So all that we're going to need to specify is we're going to need to specify the Genesis ETH1 hash, and we actually have that from here. So we're pasting that. And then we are going to specify Genesis time, which is going to be that, and I'm going to add like a number of seconds to it. So let's see if this works. So we should eventually start, producing blocks. Oh, we see published block. That looks pretty good. And then if we go back to the execution layer client, it should have picked up on, the consensus client starting to run, producing blocks, sending them back to it. So let's see if it's assembling blocks, build block. That looks perfect. So we are seeing that we have a local Shandong blockchain running with a bunch of newer EIPs. Now, one thing we can do, we have a test suite, I think, for it's spec, yeah, right. So we have a bunch of tests here that we can run to see if the EIPs have been properly implemented. So I won't go through all of them. Feel free to go through them yourself. So EIP like 3670 is like the EOF code execution, the code validation. So if you try to publish like a contract code that doesn't conform to the EOF standard, it will get rejected. We have a bunch of related tests. We have I can't exactly recall what this one is. Actually, a bad label here. Just fix that. And yeah, so we can try and see if we can run that test. I think it's in sim. Yeah. All right. So it should. Oh, I have to specify external run through. Yeah. Right. So this is going to interact with the chain that we have running locally and check if everything seems good. So we've been able to make a transfer. That's already, not so bad. And then it's going to test EOF and a couple of other, EIPs. This is a bit slow, maybe because I'm sharing the screen. I'm not sure. But yeah, we see that test running. And yeah, I'll keep that running while I keep it up, go back to the presentation. Slideshow. All right. All right, so this is where we're going to start like the more interactive and I feel like interesting part of this workshop, where, I mean, we encourage you like to bring actually your laptops out. And if you don't have a laptop or you don't feel like, coding yourself, I would really encourage you to meet up with someone or to pair with someone who actually has a laptop going, because I feel like that's probably going to be the best way that we can show you about the monorepo. And if people have like different degrees of skill levels or familiarity with like blockchain in general, we have a couple of like suggestions as to what we suggest you to do. So if you're, and that QR code is the link tree I was mentioning earlier. So it has links to all of these things along with the like Shandong testnet instructions.
I also want to mention the structure of our monorepo. You can clone the whole monorepo, and it'll come with, 12 packages. So all of the relevant packages will come in the monorepo if you clone that from GitHub. But each individual package is also installable on its own. So you can install just the transaction package or just the block package. You don't need to have the whole monorepo as a dependency. You can have each individual ETH.js package.
Yeah, exactly.
But I would encourage you today to maybe clone the whole monorepo so you can see everything and get a sense of how they all connect to each other.
Yeah. Cloning the monorepo is probably the way to go if you want to experiment a bit, especially since some of these packages are interdependent on each other. But if you were, for example, building a set of tooling and you only need to build blocks from data or build transactions from some piece of data that you have, you could only import like at Ethereum block and that Ethereum transaction, and that would be all that you need. You don't need to import the whole monorepo. It's just package based. So yeah, what we have like sort of prepared for you in terms of like paths. If you're more like I wouldn't say beginner, but like if you're more novice or if you've never really learned about Merkle Patricia trees, a good way like to explore that is with a tutorial that had been written like 2 years ago and has been like updated recently. And it basically goes through, it uses our tree package to teach you about the very fundamentals of that data structure. So it just starts with, putting a value inside the Merkle Patricia tree database, getting that value, computing a hash, looking how you can, make proofs from these hashes, eventually all the way up to, querying data on the blockchain and interacting with it more dynamically in a way that's more similar to what you'd expect in the real world context. So I'm super happy to help you as well, answer any questions on trees. It's the package I've worked the most on. In the more, I guess, intermediate track, although, I mean, Merkle Patricia trees are certainly like not super easy, so we could have put that in the intermediate track as well. You can experiment with like RLP encoding or decoding. So this is the serializing algorithm currently used by Ethereum. And we cover a bit of that in the Merkle Patricia trees tutorial. But if you want to experiment with like, what does an array containing a dog and cat strings look like when you RLP encode them, that's the package you would go for. It contains two methods, RLP.encode, RLP.decode, super simple. And you have a bunch of helpers like to convert hex to strings and stuff like that. Another, I feel like, exciting thing that you could use our packages for is the block and the transaction packages. One of the things you could do, for example, is query, just like we've done here. We've queried a block. So a good exercise would be to recompute the hash of that block from that data. We have helpers that can do it for you like super easily, where you basically just paste that JSON object and it's going to recompute like the hash, or a block object for which you can get the hash. But it's also it can also be interesting to just take those fields like manually and try to recompute the hash yourself. And we have all the helper methods you would need to do that. And if that feels a bit hard, you can look at how we actually implement our helper methods and try that out. Let me go back to the All right. In the more advanced, I guess, track. One of the things you could do is invent and implement your own EIP. That might look like super hard, but we have an example here of a super like minimalistic EIP, and I'm actually going to show that to you just so that you see how small like potential EIP can be. So I think it's 1814. Yeah, right. So it's adding like 92 lines of code, removing 2. Pretty simple. It's an EIP that goes into Shanghai, just warms the Coinbase address. So if you take this as an example, I think you're easily going to be able to, reproduce at least the scaffolding for an EIP. And you can like invent this perhaps not so useful, but like easy one where it just modifies the way maybe a block is run. It maybe modifies the name of field or something like that. And I think that PR can serve as a guideline for how to do that. And yeah, most of the implementation is actually like, it's basically just that line here in addition to like the scaffolding and a bunch of tests that are just confirm that the EIP has been implemented properly. In terms of other things that you could do, you can run the local client, as you've seen us do, and you can run the Shandong testnet with Lodestar as the consensus client. So, yeah, now it's off to the races, as Richard always says. So does everyone raise your hand if you don't have a laptop? Well, I have one, so I won't raise my hand. So everyone has one. Awesome. So was everyone able to scan that Linktree thing? All right, cool. If not, the link is just linktr.ee /Ethereum.js. Let me just bring it up. All right. So I'm wondering how to best like structure this. So either I can go through one of those myself for those who want to more follow along, but I think what would be helpful is maybe if we just help everyone, set up a local environment. And if at some point you want to follow with what I'm doing, you can do it. Or if you want to work on your own thing, you can do it as well. Does that sound good to everybody? Yeah. All right. Cool. All right. I'm just going to walk around. Might not be best for the live stream. Not that interesting to watch an empty stage, but I will be walking around. And just raise your hand if you have an issue setting up your local environment. Just clone the mono repo. It's linked at. So if you click on intermediate, it's going to bring you to the mono repo itself. Go with master.
Yeah, master.
Yeah.
Yep, just like that. So first you're going to want to install the dependencies. So if you go once that's cloned, do npm I, and it'll download dependencies for everything and build all the packages. Okay. You can do that from the mono repo. Just can I mute this?
Just let me know if there's anything.
We're part of the.
Yeah, git clone that exactly. You have it. All right. And once you've cloned mono repo, the way to install it, we use npm. So just npm install. Is anyone running on Windows? Very happy to hear that. Yeah, there's the door. Yeah, for Windows users. So I assume people are on Mac OS or Linux. Yeah. Okay, the workshop Wi-Fi's password is build it 22. Lower caps, build it, and 22 the the number. Oh, it's slow. The repo is pretty big, so it can take a couple. Here, 800 kilobytes per second. It's not too bad, but we're getting there. We have time. We have time. And yeah, make sure you're using the workshop Wi-Fi. Otherwise, it's definitely going to be much longer. Yeah. You don't run. Yeah, absolutely. So you don't need them for what we're going to do. So just npm install from the monorepo itself. Make sure to run npm install in the monorepo instead of in packages themselves. So that's going to build the whole thing, which is what we want. So within TX, what you're going to see is, I'm not sure, the docs should be up to date. So you can, build transactions from different kinds of data. So you can look like you're familiar with TypeScript. Yeah, so you can look up the types within, your coding tool. Yeah. So one thing that I would suggest you do is maybe like query pre-EIP. Okay. Pre-like EIP 1559 transaction, query a post-EIP 1559 transaction, and then try to rebuild them for with these sets of tools, and make sure you compute the right hash again and stuff like that. Yeah, I'll reopen that. Yeah. Can you hold this? Okay, for 10 minutes, I'll come back and make sure. Is everyone good? Raise your hand if you need additional help. Okay, so I think you just entered. So yeah, just you can clone the Ethereum JS monorepo. The second link, intermediate link in the link tree that you see here, and then just make sure you're on the master branch. That should be default, and then just pull the latest and npm i to install the monorepo. That should be all that you need. So just so that I do something that's relevant for most people, who's thinking of doing the Merkle Patricia trees tutorial? Awesome. Okay, cool. I would quite recommend it. It does cover some of the stuff that we would be doing in block transactions and RLP, but it just guides you through them rather than just throwing you out there. Who's thinking of just going straight intermediate and building blocks transactions? All right. And who's thinking of trying to implement their own EIP? Is anyone motivated? All right, awesome. And what about running the client or running the Shandong testnet? Okay, yeah. So I'll just be going through the tutorial as well in front, since everyone is going to be doing that. And it's going to be more interesting for people who watch the recording rather than just looking at the link tree for 1 hour. right, so I'll stop my local blockchain. Yeah, so this is the folder that you should go in if you want to do that tutorial, and the README is the tutorial itself. What we also have is a set of examples. Like I had written this tutorial in JavaScript, just so that people who wanted to learn about Ethereum, didn't know about TypeScript, didn't really have to learn about it. So those are like JS files that you can just run with a node. So let me check out. Yeah, package is named try. So once you've, let me actually just reinstall, since the Shandong thing is a bit different. Yeah, was everyone able to install successfully? Cool, no issues. Huh? You're waiting for the installation? All right, cool. Yeah, it takes a while because it's building every package, so yeah. Are you trying to run from the monorepo itself, npm run test? Yeah, it might be just because of the submodules. Indeed, like a lot of the general tests that we have depend on that those submodules. Yeah, they're pretty big. They're pretty big. I can't say for sure, like depending on the bandwidth, how long it's going to take. On my own machine at home, it doesn't take that long, but you can just leave it running and see if. Oh, that's singular test. Okay. Let me give you an example of running an individual test. I'll just go. Okay. The principle is going to be the same for all of the packages themselves. So if you go within the individual package that you're trying to run the test in, just do npm run tape, and tape is like the testing framework that we use. Then you do double. I think those are called dash in English. I'm not even sure. Then test to look at the test folder, and then you just select the file basically that you want to run, right? So if I wanted to run, for example, the proof.spec test, I would just do that, and it's going to run that test individually. If you do npm run test, it's just going to run like a massive suite of tests, including like integration tests that depend on browser integration, stuff like that, and that's typically like super long. We only do that like in the CI once in a while, but locally it's a bit tedious. So, and yeah, then you see the result of the test, it passes. So let me close that up. All right. So let me open up the tutorial again. All right, so there's a bit of preliminary info that you might want to read. Data structure of Ethereum is called a Merkle-Patricia tree. It's basically a combination of a Merkle tree and a Patricia trie. A trie is a data structure in which keys represent the path leading to a specific node. And the Merkle tree is a structure in which a parent node, the key of that is the hash of all the child nodes. A Merkle tree is interesting because if you want to prove that a certain value is part of the data, the large Merkle tree structure that you have, you can do so by providing a bunch of like sister nodes. We'll see that super clearly in the tutorial itself. So yeah, the instructions are here. They're the same that you've just run. So clone the monorepo, install it, and then go inside of the try package. So I've been going through these like fairly slowly. So feel free if you're want to go a bit faster, to just go forward and don't let me like slow you down. But the first example we're going to use the try library for is creating and updating a base try. So what does that look like? So first of all, we're importing the try class from the try package, and we can look at what that looks like. It's probably like try file, yeah. So try is simply a class, and it has a bunch of properties that you would expect on the database like structure. It does use like Checkpoint DB as like a database, and then you can provide options for the tree. So some of the options are, do you want to use this specific type of keys? Do you want to use like plain keys or hashed keys like are what is used in Ethereum? Then we instantiate the database. You could provide like your own database. Here we're instantiating a new like MapDB, and yeah, instantiating a new tree when we construct a tree with the tree class. And you can see you have a set of methods here. You can, for example, get the root of the tree. You can verify if a certain root exists. You can get, those are like these two methods are the ones we're going to be using the most. So we have a get method to retrieve a value by providing a key. And then we have a put method which stores a given value at a specific key. So fairly standard, database stuff, but this is going to give us insight into how, that actual data structure works, because it's not like a simple database. So let me go back to the tutorial. So the first thing we're going to do is like instantiate the tree. So I'll go to, I think it's example 1A. Yeah, I'm just going to comment that out. So yeah, to run a specific example, you're just going to go node examples. And for example, example 1, am I doing a typo? Oh, yeah, it's within Merkle Precious trees, and then example 1A. There we go. So this, all I'm going to be doing here, as you can see, is instantiating a new tree with, the try package from the monorepo, and then logging the root of that tree. And this is going to give us the root of the tree, which is you can look up in the docs, but it's basically the encoding of I think an empty array, RLP encoding of an empty array. So yeah, we see like pretty fast. We output a buffer, which is that. Now, that doesn't tell us a whole lot, but we could look up in the docs and see that this is actually exactly what we'd expect in as the root of a Genesis, like root of a try, like data structure. So then we're going to move on to a more interesting test, I'd say. We're gonna try to just put a value in it and see if we can actually retrieve it. Another thing we're also going to be able to see is how the root, has been updated, given that. So, yeah, what do we do here? We're creating a key. I mean, a try natively uses buffers, so we're doing like buffer from for all of these. So we're having test key, that's going to be our key, and we have test value, this is going to be our value. And then we're doing an asynchronous operation, like putting that key value pair inside of the try, and then we're going to try to retrieve that value. Fairly simple. What we should expect here is, so what should be the value? Well, it should be the encoded version, the buffer from version of test value. And the value string, we should expect to see value. And if we don't, there's been an issue, either in the library or in the way we've used it. It should also update the tree root. So one thing I'm going to do is I'm going to also log the try root before. And what we should expect is like each Merkle persistence tree, like each state tree should always have a different hash if it differs. And if it's the same, it should always have the same. So let's try running this again. So what do we have here? We start with an empty try root. Yeah, we had logged that before, actually. So the try root before, is the same. We just logged the same thing twice. The value that we've retrieved it's this. If you are familiar with that's just the hex correspondence for all of the characters. And then if we convert that to a string, we get back this value. This is exactly what we'd expect. Then we see that the try root has massively changed as you'd expect from any kind of hashing. If it differs slightly, totally different random result. All right. That clear to everybody? Does that feel intuitive? Yeah. Any questions? Mm-hmm. Yeah. Yeah. No, we're always so a normal tree. So this is the actual Merkle-Patricia tree data structure that would be used in production with Ethereum. The only slight difference is that Merkle-Patricia trees use hash keys. So instead of using the key, we'd use the hashed version of that key. And this is only to balance out the tree so that there's no vector of attack where you always update values in the similar region and make it more costly for nodes to run operations. So what I think your question is if you had a normal data structure like this, you would always traverse every single node would only give you one hex, right? Because it's a 16 width tree. So if you have a key of 32 bytes, then you would traverse all these nodes on the way down there. Now Merkle-Patricia trees are more efficient than that because if they know that given a certain path, there's only one possible path down, they're going to create what's called an extension node, which extends all the way down to the leaf. So this allows you to shortcut unnecessary paths. What you'd see if you didn't have that is there would be a bunch of layers in the Merkle-Patricia tree where there's only one specific branch that has a value, and then you go down and there's only one specific branch. So for sparse trees, meaning trees that aren't filled with data all over, this is incredibly more efficient because you don't have to store all these unnecessary nodes.
And just collapse those back up into one leaf instead of a tree with only one leaf.
Yeah, absolutely. So yeah, I'll go ahead and check what example 2 is about. Yeah, there's a couple of additional notes here that you might be interested in. Some of them I mentioned while doing it. It's also talking a bit about the RLP, encoding function. This is actually not up to date, that link. I think it's probably here. Yeah. So there's some very nice docs on ethereum.org for developers. If you're looking to learn a bit more about RLP, you would just go there. They have a bunch of examples, and you can even use our library to test it out and play around with it. So before values, so there's a bunch of values you could want to store in the Merkle-Patricia tree, right? And those need to be serialized before they are, put inside of the tree. This serialization is done with the recursive length prefix encoding function. And yeah, as I mentioned, keys also go in additional transformation. They're not used raw. They're used, we first take the KK 256 of the key before we update the tree. So here we're basically going to do the same thing, but we are going to use the hashed version of the key. So how we're going to do that is we're just going to import the KK 256 that we have in Ethereum.js/util package, And the only difference is we are going to, as you see here, put the value at the kekak of the key instead of the key itself. So everything else is going to be, exactly the same. So let's see. Yeah, similarly, we're going to get, an updated tree root. So that, nothing surprising here. It's basically just, we had an alternative key, which is the kekak of the key. We got the same value back. No difference there. Any question on that? Cool. Okay, so the values themselves aren't hashed because otherwise we wouldn't be able to retrieve them since, hashing is one way. The only thing that we hash is, this is like a key value, data structure. The value we keep, native, we just RLP encoded for, serialization so that it's compatible. But the key itself, that we're hashing. We could very well have a Merkle-Patch tree like data structure without hash keys. And however, at the early days of Ethereum, it was chosen that the keys were gonna be hashed. The main reason why that was done is so that it evens out the tree naturally. So it mitigated like vectors of attack where you could have people like constantly update like a part of the tree like very easily. And now if you wanted to do that, you'd have to like pre-compute a hash. And since it's like non-deterministic, well, it's deterministic, but you can like predict in advance what the hash is going to be. Obviously, you basically have to do like proof of work to like target like a specific part of the tree.
It imposes some randomness on the actual address, and so if you have keys that are related, they won't cluster in a part of the tree. They'll be dispersed evenly. And your key can be a short string, and it ends up 32 bytes.
Yeah. So in our case, like keys are always like addresses. Like in the case of the state tree, keys would be like the account addresses. But the kekak, like hashing something obviously also has the benefit of making everything equal length, which you want in like data structures like this. All right, so as we said, like fairly straightforward. Now we're going to do something, a little bit more interesting. Now what we've seen is that we've used the kekak 256 of the key. But there's a property of the tree that we can just use in order to do that natively. That property is called use key hashing. It's a Boolean that defaults to false, but as you can set to true if you want. When playing around with a tree, it's just more convenient to set it to false or have it default to false, just because you don't have like to do all that additional computation. It's also easier if you want to debug what a value. If you only have the hash of the key, you can never know like what was the actual key that I used to update this. You cannot retrieve it back, which is actually an issue that has also come up when making the transition from Merkle trees to Verkle trees. But that's a different topic. All right, so let's see what example 1C is about. So. Well, I think it's basically the same thing, but just using the use key hashing. So what we should expect, unless our use key hashing Boolean is implemented improperly, is we should expect exactly the same values as we have here, including the updated tree root. Given that we're using the same test key this value, that should work. So let's see. And yeah, as expected, we've created a new tree, but we've updated it with the same key value pair, and we are getting the same updated trie root. Okay. Now we're going to do a different operation. So among the operations that are possible, you can retrieve a value, you can update the tree by adding new values, you can also delete values from the tree. So let's see what this looks like. As I kind of mentioned before, every tree that is similar, that has all the same data, should compute the same root. That's how we get the security properties of these trees. So what we're going to do is we're going to update the tree. It's going to update the root, and then we're going to delete that same key, and it should give us back the exact same root that we started with. Let's look at the code. All right, yeah, we'll create it, update it, then delete using the wait deal helper method. Get it again. We shouldn't be getting a value when we try to retrieve that key. I'm not exactly sure what we're going to get. I'm not sure if it throws or it looks like it's going to be null. Fair enough. And let's see about that. All right. So we are starting out with the empty trie root here. It starts with 56E8. Then we are updating the tree. We're getting an updated tree root, which is similar to the unhashed key one we had before. And then we are deleting that value again. And what do we get back when we query that tree for that key? We get back null, which means empty. It's not there. And the tree root that we get back after the deletion is the same that we started with. So yeah, it kind of demonstrates that every same tree is going to have the same root. Yeah, so now we're going to take a bit of a deeper look at the actual, data structure of the Merkle registry tree. So it has. You want to go for this? Or?
You want me to take over?
If you want, I feel like I've been talking a lot.
No, you're a good communicator. You should do it.
All right. So there are 4 kinds of nodes in Merkle registry trees. So there's the null node, which is the one we just queried accidentally by deleting the tree. That's a non-existent node. You get back null when you query for something that doesn't exist. There is a branch node. What a branch node does is it's basically an intermediary node that points to a bunch of child nodes. There is then a leaf node, which is, this is called a tree, and the leaves are the very end. These are the nodes that contain the final values. And then there are extension nodes. Extension nodes are the shortcut I was kind of hinting to. So if you have a key, for example, we're going to see examples actually, so it might be easier. Any question before we dive into looking? We're going to look at all these 4 different kinds of nodes individually. Yeah. Yeah. Yeah, how is that initial root created? Yeah, good question. I think it's the RLP encoding. It has basically still, it's the hash of the value at that root, because it's initialized with a value. If it wasn't initialized with a value, it would just be null, initially. The way they're defined. Yeah.
I'm sorry. Are you asking about the extension node, how that root comes to be? Or?
The very first, yeah. 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 So how would we able to calculate ourselves manually the hash of the root node, the empty root node
of an empty tree?
Yeah. So yeah, we can actually look at that directly in the code. We set empty trie root that's like a specific like constant property. When we construct, when we initialize a new tree, what runs is like this constructor function. If we don't provide options, we have like default options that we provide. We instantiate the database, and then the very next thing we do is initialize the empty try root, which is exactly the thing you're asking about. This is actually quite simple. So what it is the RLP encoding of an empty string, which
it's in constants.
Yeah, constants. Okay, so it's buffer OX80, and that's like I guess sort of a
universal for empty tree.
Yeah,
or empty RLP.
Well, that's actually
the idea.
A desirable property.
Yeah.
That you can know if you could identify all empty trees from exactly that, right?
Like the same tree should always have the same root. Same with an empty tree. Every empty tree will have the same root.
Yeah, and let me take that example file actually and just compute that manually. So we're gonna need what? We're gonna need something from RLP. Let me do it in the RLP package, actually. Yeah, I'm having a bit of trouble navigating with my screen, so zoomed in.
Feel free to throw out questions or call me over if you want to chat individually.
All right, so this is importing the encode method from the RLP library. So what we should expect to get back from an empty string RLP encoding would be OX80, which is the buffer we just saw before. So I'm going to have to move out of that repo, go into the examples folder, and then run this. Am I not in the right? Oh, it's test. Okay, so why is it not logging? Always interesting when you do live coding. You don't figure out how to console log something. Yeah, I switched package before I did that. I can just actually import. Yeah, I'll just import it directly from this. Oh, it's actually in bin for that folder. All right, let's see if we can get something going now. Let me just rename that to JS file, actually. All right, it is not working at all. All right.
Okay.
We're finally
You got it.
getting back something. Now we're getting back 128. Is that OX80 in hex? Let me actually look that up.
I do believe it is.
Oh yeah, it's going to be hard to import packages in a JS file like that. Let me just look up. Okay, yeah, so 128, we got back the decimal value, but 128 is like OX80 in decimals, which is the value that we're using inside of the tree to compute the root hash. So we are basically just to compute that, root hash, we are just hashing OX80. So if we take the kickout hash of the, let me look back at a place where we were using kickac, so I don't have to re-import manually. So if we're doing the kickac 256 of a buffer from like OX80, we should expect to get back the exact same empty hash that serves as the root of an empty Merkle-Patricia tree. So let's see if we can reproduce that, ourselves. I'll just comment out the rest to remove some noise. Navigate back to the tree package. Maybe I have to put that as a string. All right, so we're getting back a uint array. I just need to convert that to hex. Then we should be getting back the same root that we initially started with. So we have a buffer to hex util in the package. Now the way my testing thing is set up might not allow me to import that. Yeah, so I would need to do buffer to hex here. Well, since I'm now running on a JS thing, I would need to build it before I'm able to run this. So I will not do this here, but those are, we can trust that, the values that are output here, if you were to convert every one of them in hex, would be the exact values of the root of the Merkle-Patricia tree that we had in the example D. XE8, that thing here. Is that a satisfactory answer to your question? Are you? Yeah. 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 Yeah, cool. Any other questions before we move on to going to all specific kinds of nodes? We're good? All right, cool. Everybody's following along? All right, nice. So yeah, we're just going to start with creating and looking up a null node. So how do we're not actually really going to create a null node. We're just going to query for a key that is not present in the Merkle-Patricia tree. So it's basically the simplest test case you could imagine. So what we're going to run is a 2A, right? Let's look just at the that's here. Yeah, so we're instantiating a new tree. We are trying to find a path, to the to the key test key, and we'll see what kind of node we'll get back. Now, what you will see now is that we're using find path, which is going to provide us with the actual node and the node object instead of just providing us with the value. So if you want to query the tree for actual values, just do get. But if you want to get more information as to what the path is and what the node looks like, you would just do find path. So we're running example 8. This provides us with a null node as we would expect. We could change that to pretty much anything, and we would get back null as well. No difference. Now, one thing I'm going to try actually is if I query buffer from that, I'm not sure if that's going to be a null node as well. Yeah, okay, that's a null node. Interesting. Oh, yeah, the thing we were using before. Yeah, I think it's still null. It's like defined as, the initial hash is defined as that, but there's no actual node that's present in that key, from what I can recall of the specs. So they're. That's kind of the initial node, but it's not actually a path, right? Yeah. Yeah. It's basically a way to bootstrap the tree so that it starts, with something. You could define like a new Merkle tree data structure that uses like something different, obviously, from RLP encoding, and also has a different like root hash. You don't necessarily have to use it. It's useful in the context of Ethereum because we obviously want to be consistent throughout like implementations, but it's not a necessary part of a data structure like that. You could define it any way that you want. So yeah, the null node is a bit boring. It's not as interesting in the ones that are to come. It's also like slightly more complicated to create because if you think about how these kind of keys work, right? You have a key, and to retrieve the value for it, you just go down. Each node is a hex value, right? So let's say the next part of the key is like 7. You go branch number 7, and then if it's 4, like in this example, you take branch number 4 and you go all the way down. Now, since like Merkle trees are like optimized with extension nodes, you wouldn't get a branch every part of the way down. What you would see is you would start at 7. Let's say you only had like one of the keys. You would start at 7. It would give you it would go you straight to the end because there's only one value that starts with 7. So it would like kind of compress the tree for you. So if we want to create a branch node that's like acts as an intermediary node, you would want to we want to store keys that are all basically in the same spot and then branch out at some point. And that's actually interesting because it's super easy to do that, with what we're going to do in this example. But if we were using a hash tree, then it's basically, impossible to do that voluntarily. And that gives you a sense of why that was chosen in the first place, right? Why we're choosing to hash keys in the context of like a production database in Ethereum to prevent like DOS style attacks with, just putting keys always in the same spot. All right, so let's look at that actual example 2B. Yeah, I'm not saving any of that. Well, it is the like native format that this tree accepts. Like it could do it, like we could have an implementation that just basically allows you to input anything, but it would still be converted into something that natively ingestible by the tree. So the tree is defined as a like hexary tree, meaning that every key must be like hexadecimal for it to be like conform to the data structure. If we didn't have hexadecimal values, we'd have to convert it anyways. So that so that it maps to like a 16 width key. So yeah. Yeah, absolutely. Yeah. So and also like RLP encoding encodes things in hexadecimal. So we're all like working with native like hexadecimals here within that tree. So yeah, if we like unlike like hashes, buffer is going to be, it's just like the hex array like encoding of these keys. So we should expect these all these values to still be quite similar, and that is what we see here. So right, we have the prefix test keys coming for all of them, and test key is basically that part, you know, of the. Let me zoom in a little bit. Yeah, that part of the buffer. Now we have 30, which is 0, and 41, which is capital A, which are, you know, the last parts of it. So what we should basically expect, right, is would you agree that we should expect like a branch node at 79, at which point, you know, it branches out? So what we would see is like there's going to be a value at 79. A branch node, you know, can have a value, but then there's going to be two paths. There's going to be path number 3 and path number 4, like indexes of the array. Then it's going to go down all the way to, you know, a leaf node, because it's basically the end of the path for that part of the path, and then 41, which is going to be the end of the part for that, you know, other path. Does that make sense to everybody? Yeah.
Yep, that's really the idea of the Patricia tree, is that you're following the keys along that path and everything that shares bytes.
Yeah, and something like to mention here, this is only keys, right? This is not the values themselves. And like later a bit in the tutorial, we see how, you know, the hashes of every like parent is computed, which is like different, you know, from this. But yeah, so if we had like also a key at just t, we would see like that would be only 74, because that's like lowercase t is 74 in hex. And we would see a branch node at 74. There would be value already there, and then there would be like nodes, like paths to all the way down to, you know, 79. It would be like, we'll see that after, but it would be like an extension node for optimization purposes. And then you have, well, branches, as we've said, to 30 and 41. So yeah, what we're going to do is update the tree with all those keys. We're going to find the path to test key, and we're going to see what that node, you know, actually looks like. All right, so that's actually a pretty nice like visualization, I think, of what's going on. So we have, you know, first the tree buffers, then we're updating with all those tree keys. So we're updating the tree with test key 0, test key A, which all have the same prefix. We query the node that lives at key test key, which is the common prefix for all of those. So what we see, so this is index, you know, 0, 1, 2, 3, 4. Which correspond to numerical values like just +1, since indexes start at 0. And actually, no, that's not true. It just correspond exactly to the actual values. And we're seeing that there are two different, you know, values here. So that is what we'd expect. We have like, this is basically like empty. So like null nodes, because there's no path at that point. Like at key 0, we don't have anything that lives at 0, right? We don't have anything that lives at 1. We have nothing that lives at 2. But starting from 3, we have an actual path. And we see that complete path here. We also have the same for 41, which is, you know, index 4. And then we have nothing all the way down. An interesting thing is we also have a value already here at address, you know, that's basically test key and hex. So a branch node is not only an intermediary node, it can also contain values, you know, itself. In the case of keys which would always have the same length, you might not see like values at an intermediary node because they all live on leaf nodes, but you can still use that data structure for other purposes where, you know, the length of keys wouldn't always be the same. right. Yeah. So that's exactly what we see. And we can take the value of that node and see if we can, like the value here, we can parse it to string. Let me find you the code so it's more revelatory of what's actually going on. So yeah, we found a path, we found a node, we take that node, we look at the value at that specific point, and it should be the value that we've put at test key. Now, if we were to take the value of one of the nodes that is a child of that parent node, we would get also like test value 0 and test value A. So it is what we're doing, a bit further down here. So let's look at how we're, retrieving that. We are taking, the third branch and the second element. That's just that's the value of of that leaf end node, converting it to a string, and then we retrieve the value back. Is that somewhat clear? Branch nodes are a bit trickier, but is everyone sort of following along? Yeah, yeah. Yeah. Yeah, so I think there's a bit more clarity about that after. So I think the next example is going to clarify that for you. And if it doesn't, we can come back to it and play a little bit more with it. It is like getting like nodes and how they're structured and how they operate within one another is the trickier part. But yeah, branch nodes and extension nodes, which are somewhat similar in structure, are the more complicated part of that. So once you get that and it kind of clicks the way they work together, you're pretty much done understanding that data structure. So it's definitely something that's worth coming back to and making sure that we understand.
So if you see that array of 16 buffers and 2 of them have keys in them, every parent, as soon as that branches out, has automatically 16 children, regardless of how many values are actually there and like where they go. If there's only one, then we can compress it down and call it an extension node. But here, where there's like 2 in that array, you just automatically have the rest of its siblings are empty buffers. And like I said, if there's only one child to that parent, we can collapse it back up. But if there's at least 2, then you're going to have an array of 16, regardless of how many actually have a leaf.
Yeah, absolutely. So this clarifies. This is a bit like in the other example, but I think this clarifies, what's going on. So it might look a bit confusing because we're using very similar keys and values. So this is actually the values, and they're also, similar, but we're not really concerned with the similarity, of the values. We're concerned with, we went all the way down to a branch node. We had 2 paths that were defined, and we had also a value that lived there. So your question is basically, well, why is it an array that lives there, right? So the array contains the 2 pieces of information that we need to finally get the value at the leaf node. So this is pointing, to a node, and it's telling you, well, actually, the remaining part of the path is going to be 3, 0. And then the remaining part of the path is going to be, 3, 1. And then the value you're going to retrieve at that, end point is going to be, that whole thing. And this is the thing that if you parse it to a string, you would get like test value 0 and test value A. And it's the reason why when we're trying to retrieve, the values here, we are, taking the corresponding indexes, but then taking the first, not the first, like the second, but index number 1. This is exactly, that's the value. Now, we're working with like fairly small values, so the values are directly inside of the tree. If you had very large values, it would point like back to another node that would have an encoding of the value. Well, at that point, it would be like the end node, so it would only be a leaf. So all the leaf contains is the last remaining part of the path that led there, and then the full value. Yeah.
And then, yeah, that'll be the root of,
Yeah, let's do that, actually. So we're going to create, so what would you suggest? Test key 01? Yeah. Let's do that. It's going to be test value, 01 as well. And actually, let me put like some fairly like different values so that we're not confused by the similarity of the values themselves. I think that
the values themselves don't determine where it is in the tree.
Yeah. So we're going to run that again. And we're going to, all that we're interested in at the moment for, this example you've suggested is the branch node. Like, what does it look like at that point? And then it's going to have a child that's also going to be a branch node, right? That's what we would, expect. So let's try. I need to save it first. Let's try running that. All right. So what we see is it's actually quite similar to what it was before. But instead of getting an array, we're getting a larger buffer. So what is that larger buffer? That larger buffer is, now there's two kinds of keys in Merkle tree trees. That's just a hash that points to a different node, right? So it's not about, path. Path is still like path, number 3. But to know like what's the hash of that other node that we're trying to retrieve, this is going to be that. So that's just a hash of the child node that is going to be the one that contains, 0. What was it, like 0 and 0, 0, 1, right? So now. Yeah. So let's see how we can go about. What I'll do next is look at the path at test key 0, right? And we're going to look at what, that actual node looks like. I can also remove that. All right. So what do we have here? What am I logging? Okay. So if we look at those keys, you have a common path, that is test key 0, and then you have a slightly longer path, that is test key 1. So what we should expect, again, is a branch node at that point. It's going to contain the value itself because test key 0 is actually defined, as a valid key that contains a value, but it's also going to continue at 1. And now, obviously, we're dealing with hex conversions of this, so it's not going to be at the actual index 1. It's going to be at a different index. But we do see that there's exactly one valid, branch that points to another node, and then there's an actual value here. And if we were to, convert that actual value to a string, we would expect to get back whatever, like garbage I typed in there, and this is exactly what we retrieve here. And if we look at this branch, we're going to try to retrieve that, number 3 thing here. I can just do it. So what's the index of this? It looks like, okay, index 3. I have to do actually branches. True. And then this would be the remaining part of the path, and this is going to be the value. So if we do to string, we should expect to retrieve that number 3, thing that we had above. Let's see if that works. And yeah, we're getting back, number 3. Well, I kind of messed this up. I should have commented this out. Not necessarily. This is just because of the actual key that we use. So it could very well, like if I choose, if I do 2 here, and we go back to just logging. No. I don't expect we'll end up with not indexed number 3.
Can you repeat that?
Being displayed,
Mm-hmm.
and you have referring to the branches in the terminal, right? Like we have buffer placeholders, and the value of the key is being shown as 0, 1, 2, 3 on the third element. Mm-hmm. Is that right?
Yeah.
So in that scenario, the total number of buffer placeholders are 15, 1, 5. Is that right?
Yeah, it's actually 16. We have 16 elements in the array, I believe. It ends up, the end index is 15, but it starts at 0, so we have 16. And all the options are for, I can try speaking with the 16 indexes would be like from 0 to F, depending on which, what is the next key of
The next byte.
Got it. Thank you.
I should be able to generate another one, actually. Not sure what I always. Am I running the right test? Can we? Oh yeah, it works. Oh, okay, I know what that is. So 0 is actually like it's encoded as like 2 hexarray, number is only like not a single one. So we're seeing 3 because that's the like second number of the 0. At which point, we have a value like directly there, but we're branching out. So I think if I created like another one. Might be a bit tricky to actually create all the cases that we'd want. We might end up with the same sort of issue. Yeah, so here we're getting, again, like you remember how we were getting like a path and a value? That was because that was the only value left. Now we're again getting a hash pointing to the common path of like the next one. It's going to be a branch node again. We could, again query find the path to that.
But in this case, there's no value at that node. That's just pointing to child nodes.
Yeah, well, there's a value. Like if I query test key 02, there's going to be again a value here. But yeah, I'm not actually sure why we're always at this index. I'd have to look at the way this is encoded. I suspect it's like always the latter part of the number 2 is what's used here instead of 3 itself. I can't recall exactly why that is, but yeah, we in a normal like setting with like keys and stuff, we would expect like every basically level to branch out, and the fact that it's 3 at the moment. It's just a peculiarity of the test case I've come up with. Yeah. Yeah, lowercase, uppercase, yeah. Yeah, it's not lining up perfectly to, yeah, exactly. So if we wanted to, like if we could natively like compute, you know, buffers and hexes, then it would be much easier to see what's going on. Now we're using like human readable keys. So, I mean, they're broken down to that they're, you know, they're converted to hex. So at each part of the way down that we go, it doesn't line up exactly with the end of the key. There's often like one next like character necessary to finalize the number 0, for example. All right, so I'll go over.
We have 3 minutes.
Oh, we have 3 minutes actually.
So I think maybe open up to just like general questions or comments or anything. You know, we're building this for you guys, so if there are things that are not working or confusing or that you'd like to see, we're very open to feedback and suggestions and help.
Yeah, so like most of what we've done so far has been like working on, you know, just Merkle Patricia trees themselves. A bit further down in that tutorial, like I encourage you to just keep going at home and ping me like on Discord or Telegram or Twitter if anything like doesn't work as you'd expect. But there are like, we're working also like with blocks and with transactions and RLP encoding, which is quite, I feel like it's how I learned about Ethereum initially, like through learning about these data structures. And the first draft of that tutorial was actually like me learning, you know, about this stuff and figuring out what's going on. And yeah.
And yeah, we're an open source project. You can find us on GitHub. You can find us on Discord and chime in or ask questions.
Yeah, we have a massive number of external contributors who've helped, you know, over the years. The repo is fairly old. I think it's like 6 years old or perhaps like even more than that. Sometimes I'll work on a part of the code and I'm seeing like the Git blind like five years ago or something like that. So it's really like a pretty old repo. We are extremely open to external contributors. Like sometimes we'll have people come up and just help out, and then we include them in the team, like not in the formal like team itself, but we do like chat with them and are always happy to help people, you know, help the project we're working on. Our future projects are, we're trying to improve the client syncing. At the moment, we only have full sync. It's super slow, and you would never use that, you know, in production, obviously. We're trying to do, you know, general like optimizations as well. So if anyone like is competent at that, we're really happy to like get you started on that. We're improving like the JSON RPC endpoints. We don't yet serve all the RPC calls.
It's an excellent place to start if you want to help out. Just implement a new RPC endpoint for us.
Exactly. You can just go through the list of what we've implemented and just, you know, come up, you know, with easy ones that you want to implement, and it's a good way to get started learning about our repo. On my side, I'm working more on R&D for Virgil trees and statelessness, which is, you know, sort of related to the Merkle tree stuff we've been exploring. Scotty works on ultralight, amongst other things. And yeah, we're just improving the code base as well, making it nicer with nicer types and better performance. Any last questions? Oh, that's a good point. Yeah, I didn't think of adding that to the link tree. I will, that link tree linked above, I'll update it with a link to our Discord so that then you can come in. It's the Ethereum.js Discord. Probably fairly easy to find as well, but I'll link it nevertheless.
Yeah, I feel like one last question. I had a friend who actually worked with Ethereum.js, and he was like telling me about like, he also used that. Is this actually interconnected just for Ethereum.js, or it can be like interoperable in other, like, I don't know, proof of history, like Solana or something like that. I don't know if I'm just telling nonsense, but he was telling me like he used that for our RCP support, kind of a thing. How does it work? Because I was kind of confused, and like he was actually using Ethereum JS for connecting with Solana.
Yeah, so it's an interesting question. So we've increasingly made our packages configurable. So one of the things we've done in the past year is we allow you to provide your own VM or EVM implementation. So you could have a chain that is not like strictly EVM, or maybe that has like peculiarities or that are EVM-like but not like strictly the same. And you can just like parse that in when you instantiate, for example, the client. You can provide your own like whatever like rules you have for your blockchain. There's obviously like a limit to that. Like there's a point where it's probably better just to build something else if it's like super different, but it's still quite configurable. So you could also like, there are chains like Scylla, I think, which has like different rules for computing transaction hashes and stuff like that. I haven't worked with that, so I'm not sure how easy it would be to configure it, but you can definitely adjust some parts of the code and provide your own like hashing algorithm and use that instead. Same thing with like the Merkle trees thing we've been working with. You could provide your own hashing algorithm. It defaults to KEKAK, but I mean, you can use whatever you want.
Okay, thank you.
Yeah. Other questions?
Thanks for coming.
Yeah, thanks for coming.
We didn't cover vertical trees here, no.
No. A preliminary learning for eventual vertical trees is what we went over. We didn't cover vertical trees, no. Oh, yeah. This thing.
Thanks for participating.
Happy to hear that, yeah.
Yeah, there's a lot of information to digest, so you can give me like probably Telegram.
Yeah, sure.
Probably I will take time to just learn. I'll build myself with it. That's what
Scotty.
Joe.
Nice to meet you, Jeff.
Yeah, this is pretty interesting. I was actually going to end up asking about how this, like, what part of this changes when you end up with vertical trees, and I was like, I don't know, this feels like this was the novice section. Like, I'm asking all these questions, and I'm like, I feel like I'm messing this up.
No, that's fine, I guess.
Yeah, I mean, we're trying to avoid a workshop where we just walk people through the stack because it's been, plenty going on here. But I think this like.
Test. Hello. Welcome to the ERC Lightning Talks. It's 1 p.m. in Bogotá, in case you are still a little bit hungover or whatever. My name is Tim. Annette is currently still in a podcast interview, but I think she will come also later. I'm quickly gonna give an overview of what's gonna happen in the next, I think we have like 1.5 hours. You can already see a bit on my drawn slides. I don't like PowerPoint that much. What will be essentially like the content of this entire session. We have lined up like 6-7 speakers, including me. We are going to center all of these talks around the Ethereum magicians, and specifically we're going to talk about ERC proposals, so Ethereum requests for comments, right? So basically everything that didn't fit into Annette and Tim Baiko's earlier session, I think like it was about 2 days ago, about the Ethereum core roadmap. So how this works, each speaker has roughly 15 minutes, and then we have usually like a 5-minute break where we can set up the next speaker. And maybe there's even like time for questions, I guess. We will have some talks about timestamps in Ethereum get logs from Ronan that just entered the room by chance. We will have some talks about soulbound tokens, about music NFTs, about DSOC. We will have 2 people speaking about the problems in the Web3 music space. About content types in NFTs, and then we'll also have a very recent EIP, namely, I think it's for the domain separator in EIP 7.12. So I wanna give before like we start with the speakers, I think I wanna give a quick talk myself, though kind of like my own lightning talk, and I want to make it about kind of this weird thing that the ERCs are, which are essentially this like immutable contracts that are almost like as immutable as a transaction in Ethereum, and the problem that comes with it, which is that like we don't really know how to upgrade them, and throughout this whole year of bull market and everything, especially in the NFT ecosystem. I think there's starting to be this debate basically around like how can we actually do innovation with these contracts if you cannot change them anymore, right? And so like what can we do about it? And I've tried to kind of like express that where like this contract, this document, this proposal, that once you put it into the final status, then it's really like locked, like this lock, and we can't really unlock it anymore. And so we have to find ways of like still upgrading it. And that's what I want to try to motivate that actually, and I want to try to make like an optimistic case for why it's actually cool. So, but first of all, I think we have to backtrack a bit, and this is a comment from I believe the GitHub thread on EIP 26.12, the permit standard that allows you, basically it's like a replacement for EIP 20 tokens, where instead of sending the approval on chain and like kind of like wasting all of this gas for the transaction envelope, you technically could sign a transaction that gives the spending contract the permission with your signature. And so the idea, I guess, would have been that new use cases are kind of enabled, and that also we can save a lot of gas, especially like considering that each EIP 20 transfer is essentially like 2 transfers, right, today. And so if we could already condense that to 1, I think the gas savings would be quite significant, considering like how much we are transacting with EIP 20 tokens. So this comment is actually a critique, though, on that standard, and basically I don't even like fully know the entire history, but I know that I think the standard has like some issues. It's not really in final mode either, and then like many companies have like
kind of diverged from it, and they're like non-compliantness, like I think with this standard. So it kind of shows, I think, maybe a bearish case for this kind of standardization approach. And then the other case, which I had to deal with myself personally, because I crawl NFTs, this is the interface for the Zora M NFT contract, and M stands for Media NFT. And, you know, I think my first exposure to this was that I was kind of like disappointed, because essentially when you call the token URI, like the regular token URI, you are expecting a JSON, and but what I'm getting back is a media file. And so I have to actually go to the token metadata URI, and that's where the metadata is, right? I mean, the name is descriptive of that. And so I was a bit disappointed, because I had to basically build like this like custom logic around it. But on the other hand, I'm also empathetic with that, because in the regular NFT, the media file, which has been like traditionally the image, is literally in a JSON object that we call metadata. So, I mean, in my opinion, that says a lot about how we think about NFTs, and that we see the image, or like the media that is attached to the NFT, kind of like as metadata to something that is the NFT, that is kind of like maybe like a financial instrument then, or whatever. And so I think it's actually beautiful that they made the case that we should actually use the token URI to embed the media file directly, and to center really the NFT around the media file, and not make the media file a mere metadata field. So, yeah. And apart from all of this like pessimism, I think there's another good reason for submitting and being active on this forum, and it's because you get a ton of exposure to your ideas. So this is a thread here that I made, I think around in April, and it's about like a specification for soul-bound tokens, or we now call them account-bound tokens. And this thread has gotten 9,000 views, and if you would sort by the replies, it's actually the top controversial thread on the entire forum for the entire year, apparently. So, I mean, while that is concerning to me, because apparently a lot of people have opinions about this, it's also, on the other hand, it was like a beautiful chance of receiving feedback, and also of receiving constructive feedback, which without that, this standard wouldn't have gone where it went today. So I initially started this as a non-transferable token specification, and basically now we have like moved into consensual minting, and into like, yeah, basically like having the signature being checked by both the sender and the receiver. And, you know, we are actively talking about all of the privacy challenges of soul-bound tokens. And so this has really become basically like a space where this entire standard, all the soul-bound token things, everything is like very verbosely documented. And I think it's awesome, because I wouldn't have had these ideas by myself. So I think this is like a community effort, and it's cool. And so, by the way, I'm like, basically these slides are all a Eve Magician's blog post, essentially. And I need to find a bit my way. But so basically one of the problems of the EIP standards process is that it's truly permissionless, and it's open to everyone, essentially, because you can just go to like the like github.com/Ethereum/EIPs, and you can submit your own EIP, and as long as you are complying to the formatting rules, and you're like, you're like receptive to the feedback of the EIP editors, and you're not like mean to them or whatever, you will actually get your document merged, and that document will show up on eips.ethereum.org. So that's really cool. And that's really a strength, but it's also a weakness. And I think this, I guess it's like a bit of a famous cartoon in the standards community, at least, where like this XKCD comic, where there's like 14 competing standards for a use case, and then there's this one guy saying, hey, that's crazy. Like, why do we need 14 standards? We should have one standard that has all of the that addresses all of the use case, and suddenly we have like 15 standards, right? So it's kind of a problem in the ERC process as well, that we just have like a lot of verbosity and duplication and so on. So it's like, on one side we have like the strength, the openness, and also this like, it's almost like a spam problem or whatever. But I wanna still motivate, and I wanna say that I find this actually awesome. And I find it awesome because I think that there's a difference between a temporarily emergent consensus and a consensus that is more like spontaneous and probably like from this kind of like, like group or a committee of experts. And so I've tried to visualize that with the two different kind of approaches, the two different extremes, so to say, where, on one side we have more like a market-driven adoption where the individual kind of makes the decision by themselves. They do all of the due diligence and they come to the conclusion that they want to use a standard. And then on the other hand, and this is maybe true for like more I think like groups that have to make decisions rather quickly and like close to time. I think you have this basically this spontaneous committee consensus where 51% can basically overrule the 49%. And I want to make I just want to kind of make this argument that I believe that the temporarily continuously emergent consensus is actually the cooler one, the one that has like that ends up having like a stronger signal over time. And that's because I mean there's one hacky way of just like proving that, and that's that if you consider like how organizations are run today, then it's probably mostly in like this 51% consensus style, right? And then on the other side, you have this totally chaotic, evolutionary kind of thing that is the market that somehow also figures out like what is the best decision, but completely different and not by talking to each other. And so I think, and I mean, by no means is this financial advice, but I would always bet on the market and not on like an individual committee actually. And so I think that's actually the better approach. And also, I mean, I guess it's also the reason why like much of our critical infrastructure is like run in that way. Like I don't think there's like a like a central planning for the food network in a city or stuff like that. And so the question is though, like, how can we overcome this immutability of contracts, and how can we actually still innovate on those standards? And this is especially true with all of the like this all of the eyeballs that have like went into the NFT space and kind of this difficulty of innovating with the standard, and I mean sadly also with being non-compliant to the standard and just trying to grow externally from standards. And so I think immutability does not necessarily mean stagnation. I think actually there is now, we are starting to see a pattern emerge where people are starting to really upgrade the standard, and they're doing it in a way where they're basically like bolting kind of this one lock to the other, almost like a like in I don't know, on these bridges that sometimes you can see as a tourist kind of thing. So I think over the last half a year that has really happened. So for example, we now have a standard event for emitting an event when the metadata is updated in an NFT standard, and that's the one on the top right. It's the 4906 that essentially just emits an event. We now have a very interesting standard that basically splits the user and the owner into two different groups. And I think especially with with DSOC kind of making us aware that there are only that there are like subsets of ownership where kind of ownership represents this bucket of right, and then you can have fructus and you can have usus and ab usus and so on. This is starting to become really, really interesting, right? Where we have like different kind of roles that could interact with the NFT, and then this could have like different economies. And so I want to give a shout out. That's 4907. And then I guess maybe like a more infamous one is the royalties one, and it's the 2981, and that's basically an optional an optional royalties allocation mechanism for NFTs that is implemented, I think, in many NFT marketplaces. And again, I just want to highlight that I think it is definitely possible to upgrade these things, and like we are doing that. I just think that probably the time horizon that we're looking at this, and where we're like drawn to being a bit more pessimistic. I think maybe personally, maybe I have to be more patient and just like trust in the process. And I guess I have 5 more minutes. So I'm also gonna, of course, I'm gonna shill a standard that I did myself, which is the minimum soulbound token, and it works in the exact same way, where basically we are extending and even breaking the EIP 721 interface, and essentially we're allowing people to lock an NFT. So you can emit a locked event and an unlocked event depending on whether the transfer function should be reverting or not. And then we also have this view function that allows you to always check whether a token is locked. And the purpose for this is that that if you were to just use like the plain 721 standard, which actually it has a kind of like a small line in it where it says like that these NFTs can also be used as a read-only registry. The problem is that indexers and wallets and so on wouldn't really recognize it, because a computer cannot reason from, let's say, the transfers reverting to, this thing is like locked, because it could also be that you have done like something else wrong, and so therefore the error might be referring to something else. So I personally think that's useful, and that's final now also, and it's building on 721. Yeah, now I'm at 17 minutes. We're gonna have the next speaker. Thank you for also giving me the chance to give this little talk, and I want to ask to stage Ronan Waga. I don't know the exact pronunciation. Thank you. Otherwise, we also have other things. And then so you have I will update it if you want. And then this just works. But reward. I get one thing where you can have questions. I think you can do it. We are a bit before time, so I think it's fine. It's fine. This on.
So I can start. Okay, thank you for coming here. Here I want to present a very simple proposal, and kind of to explain it, I wanted to show a demo, and I wanted to show it in real time. But the Wi-Fi made me realize that I should probably have it already done and show you the result. So basically the proposal is to improve. So what I'm building, I'm building a indexer so that kind of take all the event of a contract and construct the state, which is our most smart contract system handle state for the client, for basically having data about it. And most projects use a backend, which is at odds with the vision of decentralized application. So here my idea was simply, let's index in the browser. And of course, it doesn't work for everything because of the scale of some of these systems. So for example, if you wanted to index all the NFT, you could do in the browser, but it will take a while. But for some other case, it actually worked very well. And so I have this game. So the whole state of the game is actually here. So you have all the fleet. So it's a game in space. You have planet and fleets. It kind of has the two main things. And it's like, I think this state is around 7 megabytes, but it's not actually, I didn't implement a full, so I have an index, I have the same indexer running on the graph. And I didn't finish to implement it fully here. So I expect maybe to get to 20 megabytes of state. And I can, on a normal network, I don't know what normal means, but it took 5 seconds to sync the whole thing. And you can obviously, but I made an assumption that in my game, there is this notion of time. So every event, so the state, the contract will kind of lazily update per time. And I think it's quite a common thing in smart contract. And unfortunately, when you fetch the logs, which is a mechanism by which you index and manage to get back the state, all these events basically, which you don't have access to the timestamp at which they happen. It just, for some reason, they didn't thought to add that. So there is a block hash, a block number, but there is no block timestamp. And so my game actually, when I need the timestamp, and so because I don't have the timestamp in the logs, I get like 20,000 events here. And what I need to do then, I need to request 20,000 times, depending, I mean, a bit less because you can have same event, an event in the same block, but I have to request that on top. And because it's an in-browser indexer, it uses EIP 1193, which is like the wallet interface. And I cannot do batch request. I have to do all these requests. And so I have this version, we actually is still running from last time. And sometimes error out because the RPC is not happy that time. So the RPC of MetaMask, because again here, it's just a static web page. There is nothing, no backend, and it all only rely on the fact that the user have a EIP 1193 wallet. In that case, it's MetaMask, and if you look at my settings, it's actually an RPC somewhere else. But so it's still querying all of this to get the timestamp, while the other one have been finished a long time ago, and only actually you see 580 requests. It's actually 300 because the other one now is just to get the latest block, and nothing is really happening in that game right now. While this one is still like fetching the state, so it's going to reach probably 20,000 to sync, or maybe even more. Yeah, so the proposal, I wanted to show you a kind of a really example, but the proposal is basically to add this to the JSON object. So it's a very simple change you can do in your node. So in Go Ethereum or whatever. And so actually, funnily enough, like Tim pushed me to go to the core dev meeting the other day, and actually I'm going to. And so we had an interesting discussion about it. But so I kind of, so most of it I already said. But the idea is that so what I could do is that I could add the timestamp to the event itself. But obviously, when you do your contract, you know that there is a block information, so there is no need to add the timestamp to the event. It's just a waste of gas. And time is an important aspect of many smart contracts, and block number cannot be a replacement for them. And the reason why is because block number timings can change across chains, but also there is no guarantee that a single chain will not keep it. And you could probably emulate an average block time using smart contract itself, but it's kind of a ugly workaround. And block timestamp already easily available, like the block hash or the block number. And so I've been discussing about a few people yeah, but this is extra data you have to put in the log object. But it's small, and the alternative is to fetch all of these anyway. So of course, for the one who don't care about timestamp, then they have an extra small, but I feel it's small enough. I also consider alternative, but I would not consider as alternative. Actually, I could consider them as complementary. So when I mention them, I'm not saying I don't want them. Actually, I want them, but I feel they will not replace. Thank you. So yeah, basically, one alternative is to add a batch API for EIP 1193. It was actually part of the conversation initially, but it was dropped. But I think it's a valid one to have. But my opinion, it doesn't offer the same advantage as having the block timestamp in the log. And another EIP that I didn't see it yet is to have a GraphQL API. So basically an alternative to EIP 1193. And with GraphQL, you can ask what you want, which make it more efficient as well for transferring data. So if you don't care about the timestamp, you don't need. And actually, this one could really, by actually solving the first one. So this one is really an alternative, but I don't see any reason to just add other one. Especially, I think GraphQL is not supported in all the node implementation today. And so as I say, I went to the core dev and we had the feedback. And the main feedback was that there is no point to do it because we are going to make the logs not being accessible after a certain time. And so the argument was like, you will never have that many logs, and so requesting the timestamp anyway won't matter. And so my reply is that, so it's an easy change. So my next action will be to make a PR, I guess, for Go Ethereum. And the number of log actually can still be significant. So even if we remove past log, we still want to have access to them. But actually, the main issue with that feedback is that we need to really think how we are going to solve the state access about if we don't have access to past logs, how we are going to index in a decentralized manner. Because of course, if you have a backend, you solve your problem. But we don't want to have a backend, right? You want to be able to use Tornado Cache from your browser without only relying on your node. And so I think, I don't know, for me that I would like to have discussion as a community how we can solve that. Like, I know there is work on the around, like right now, about Portal network. And so, but I think it's important we understand like the point of view of application developer that don't want to be involved with our application once it's launched. And another thing, yeah. So I mentioned like most systems already rely on the log event, so we need this system anyway. And even some EIP have been using it to kind of speed up the need or kind of minimize the gas cost, which is EIP 1155. Like you can't query the balance of all the tokens that the user owns from the smart contract, and so you allow the smart contract to be more efficient. And it's because it has been the result of everybody acknowledging that we use logs and events to reconstruct the state. But that, interestingly, one of the things in the core dev meeting was that was not the vision initially. But now we evolve, we understand what we need, and so I think, yeah, that I will end with like, yeah, let's discuss about how to solve this, being able to rebuild the state from the client. It's kind of all for me. Yeah, any question?
Thank you, Ronan. Thank you. Hand of applause. So we have time for questions. Do we have any questions?
What are your thoughts on using getters in the contract? what are your thoughts on using getters in the contract as opposed to events to get the data for UI?
Yeah, so I can talk about my game actually on that front. So the first version, I really wanted to launch the first version without any backend. So the first version of the game, the first alpha, I didn't have an indexer using the log, and I was fetching all the data. And it's not efficient neither, because especially list of things, and you are wasting gas to support that in many cases. So this is why I mentioned EIP 1155, not having access to the balance. And we could also think about 721 enumerable extension, which add actually a lot of gas cost overall. And I think from what we have seen, everybody like event to do that role. So I think that's what we should do and minimize the role minimize the gas cost. Basically, that's what we want. We minimize the things that happen on the chain if we can do it off chain, but this assume we have a system to retrieve it. That's why I think it's important to discuss, because maybe the conclusion is like, oh, actually we cannot and we have to pay gas to do that, but I hope it's not the case. Any other question?
No? Can I go speak? Okay. Any other questions? Thank you. Okay. Hi, everyone. I'm Annette, and I would like to quickly just say hi to you. And I'm sorry for being late. I was recording podcast, so I just ran downstairs from recording. But I would love to welcome you guys on this session. It's been a pleasure to host this one with Tim, who is a huge, who is, you're very involved in the NFT ecosystem. And I'm just going to quickly introduce myself. So I'm Annette, and I used to work, I used to create the NFT standards, the WTF documentation for all NFT-related ERCs. I did a huge research on that. I wrote many articles which are up on my Medium. I'm sorry I don't have a slide, because I was really not thinking about this. Also, this session, we put this together when I was literally on my flight down to Bogotá from Europe. So this was extremely last minute, and I'm so grateful for you all to be there. As this was totally last minute. We literally put it up a couple days ago. And I'm just going to probably quickly just tell you a little bit about ERCs, especially as there was a lot of misconceptions between what is EIP and what is ERC. And I'm just going to use my article that I released a couple weeks ago, on September 14, which was a month ago, which was the guidelines on how to write an EIP. So I'm just going to quickly guide you through this. Especially as I noticed that there is many misconceptions of what the heck is AIP and what the heck is ERC and what is the difference between AIP and ERC. So EIP stands for Ethereum Improvement Proposal. And it's sort of a standard, or it's a way how standards or improvements or the Ethereum itself gets improved. There are many categories of AIPs itself. One of them is the ERC. ERC stands for Ethereum Request for Comments. And that's sort of the main thing. And ERCs are also the application layer AIPs. So if you guys are building anything like the application layer, decentralized application, if that's not familiar word with you. So that's what ERC stands for. And then, oh my gosh, what I'm even going to talk about? I'm sorry, I did not prepare anything for this. But what I'm just going to talk about is probably just check out the wiki. There are many cool things in the wiki itself. There are many cool standards. Also ERC, 1155 is probably my favorite ERC. Is that something that people ask me for? Oh my gosh, I'm talking so random. I'm sorry. But also huge kudos to Tim to like putting this session up and to like inviting you all to speak and to have a lightning talk and to give you guys all opportunity to just tell us a little bit about your ERC itself. And especially I'm very excited about the development that Tim has been sort of like pushing from the soulbound token perspective, but also from like it's from NFT standards community, which I started like in like I don't know 2 years ago, I think. Many different communities emerged. One of them was the music NFT community, which is a very huge one. And I'm not sure if we have somebody from music NFT industry here. Okay, we have 2 speakers there. Awesome. Thank you guys for presenting music NFTs here. It's amazing to see music NFT space involved as well from the standards perspective, but then also the soulbound tokens, which for me feels a little bit controversial. Like, are soulbound tokens even like NFTs itself? I would say probably not even, but that's maybe too controversial take. And then like a bunch of different. How much time do I have? Okay. No, I'm like talking so random. But I would say just go to my Medium and then you can like find a bunch of like other stuff there. Yeah, my recent article was on like do's and don'ts of the AIP writing, or like how to write AIP, which I highly recommend you all to check out. I can like share the QR code afterwards with like the article itself, if anybody is interested in that. But then, yeah, definitely check out the wiki. That's where you can find all information. I don't think so. If I have like soulbound tokens there, because I literally had no time to like maintain the wiki lately, because I just joined Nethermind like a month ago. But I'm very happy to see more people to get involved in the community and like taking care of my baby and like pushing it forward. And I'm very grateful for even like, as I see Ian there from Zora, and he was one of the first people who got involved with the NFT standards community, and he was like very happy to like answer all the questions and like get engaged in the discussions in the community. And I'm extremely grateful for you all to have you there and to just like speak up and like represent the AIP itself and like improve the ecosystem from the ERC, like the ERC ecosystem, and like building up on the NFT ERCs. And I think, yeah, we have all of them should be like the NFT related ERCs. So thank you all for taking the baby that I basically created, the NFT standards wiki in the community, and like building up on. And huge kudos to all of you for like showing up to this session and representing. And especially as this was like extremely last minute, like guys, like wow, thank you.
Thank you, Annette. And yeah, next speaker, please, Raul. Raul is actually going to talk about a standard that I have co-authored, so I'm very excited about this. So yeah, give a hand of applause for Raul.
Hello everyone. I'm gonna start my timer so I have a reference point here. Yeah, this is my first time actually talking at Devcon. This is my second Devcon. And I'm super happy to be contributing back and sharing knowledge and sparking debate and ideas. So Thanks for having me, and thanks, Tim, for organizing this as well, Annette. So today I wanted to talk about EIP 4973, badges, and definancializing DAOs and beyond as well. So firstly, a little bit about me. My name is Rahul. I'm co-founder of this little baby company that we started called OrderSpace. And I've been in the crypto ecosystem since 2016. I started off with my journey also with music. I was building NFTs to assetize music royalties back in 2017. Did not work. Then moved on to SoundCloud, got FOMO with DAOs, and I got back to crypto full time now. So I think I want to start with how this year had started, actually. We think that there was this paper called Decentralized Society, and it centered our attention on this notion that Web3 centers around expressing transferable financial assets rather than encoding social relationships of trust. When everything is transferable, things can be sold to the highest bidder. So, we wanted to challenge that, and that's what that problem is what gave to this idea. And working with Tim on this EIP, what we called account-bound tokens. Not to be confused with soul-bound tokens, or you may be, but semantically speaking, we kind of you can define this as non-transferable tokens bound to an account. And then our goal here was to really, it's very semantic based again, like to kind of create special ownership deeds or creating like permission primitives, but really to create a new ownership experience through this primitive. You can read more about this. We have written a more extensive article on this. However, ever since we started, we noticed this account-bound tokens debate had kind of like exploded. There's soul-bound tokens, there was community-bound tokens, ENS name-bound tokens, now human-bound tokens. What we're actually seeing is this non-transferable tokens is a spectrum, and you can define what is being bound to and what is that binding strategy, and you can kind of this is where the explosion of ideas are coming. And as a builder, I feel like some of the NFT spec is kind of over-optimized for what we actually express our ideas through. So we're kind of like craving for new tools and new instruments to kind of like build our ideas, right? And at OrderSpace, we call something smaller, something simpler. We call them badges, which is powered by EIP 4973 account-bound tokens. So I want to dive right into it, because ever since soul-bound tokens was kind of like really a hot topic, it kind of sparked like a lot of hot debates. And its debates are great, because it really helped us intellectually navigate the space and like get like a pluralistic opinion from various parties. One of the first things or concerns they put out, I think, was permanence. What if I don't want a soul-bound token or an account-bound token, anymore? And the second one is a lack of consent. What if I get an NFT that's non-transferable airdrop to me with my personal details? What would happen? And key rotation. What if I lose access to my key wallet, or I want to to my wallet, or I want to change my wallet? And lastly, this more popular active debate about verifiable credentials and ABTs, on-chain versus off-chain, identity, so lots of things. Very simply put, we've written, again, lots of detail on this, but I can kind of summarize this. These were the design decisions that helped us input into EIP 4973. So permanence, when we talk about in general, what we baked into it is burning and dissociation from so the owner of the soul-bound token or account-bound token can dissociate from the token itself. And then lack of consent. Non-transferable tokens through account-bound tokens cannot be airdropped. You need to have two-way consent, which I will dive into a little bit later. And with OrderSpace, we're actually actively looking into recovery mechanisms like community-based recovery, especially if you lose access and you have all these non-transferable tokens. And lastly, ABTs versus verifiable credentials. use both, really. It's not mutually exclusive. They have like good use cases, and it's really, we're in the early stages of kind of like the debate and application, so I'm kind of excited of what would actually come out of this next year. So like on a very high level, like I'm oversimplifying this, but like you can see the key differences. Like if you look at like various angles or various dimensions, right? If you look at transferability, consent, removal, issuance, expiration, and fungibility. But I think I want to bring focus to where consent and issuance. That's really what we wanted to did not want to compromise on when it came to non-transferable token design. So let's dive right in. So this is the ERC 4973 at a glance. You can just npm install that, very easy. So that's a very, very light interface, right? Like it's just expresses. So we can kind of dive into what this actually does. So firstly, this top section, right? This transfer event, balance off, owner off. This was mainly to ensure backward compatibility to NFT in general. So we actually implement the IERC 721 metadata. So one of the things, building this EIP actually, it was super amazing learning experience. We actually didn't have the transfer event first, and then we were kind of missing all this stuff, like Etherscan was not showing the log events, for example, or MetaMask was not showing the interesting metadata. So we actually started using the transfer event, which is such a simple change. Everything started working automatically. The support, the interoperability actually came for free, and that's one of the reasons we went back to the transfer event. Although in a non-transferable event token, you can argue that transfer makes no sense. But this was one of the design decisions that we learned, to kind of ensure backward compatibility. And the next one, and this is really where the consent really comes into play. So if you see the function, there's three parameters, right? Like the from, the URI, and the signature. So we call this a take flow. So you cannot actually mint an account-bound token unless it's two parties involved. So it's like a peer-to-peer, fully mutually consented protocol, right? So you can think about this as okay, Alice designs an ABT described by a spec, which is hosted by the token URI. Alice then wants to issue the ABT to Bob. Alice can only do that if she signs using EIP 712 signature and that's capturing her consent. So now that one-party consent is established, Bob can now take the SBT. He would then basically authenticate by providing the token URI, the signature, and from Alice, and then prove that I can take this. So this is, in Autospace, we actually call this the allow list flow. So I'm just adding people to an allow list. I'm signing people to a badge. And the give flow is actually its inverse. It's when Alice designs an ABT, Bob wants the ABT, so signs it, and then Alice can now give the ABT to Bob. So this, in Autospace, we call it the airdrop flow. So if you give a badge, you can just basically, I want this, and 100 people say I want this, you can actually do an airdrop through an account-bound token. And the last bit is this one. It's the unequip. This basically means complete dissociation from the account-bound token. So only the owner of the token can dissociate. So these are basically the fundamental building blocks that kind of help us create this very bare minimum, very simple, very highly functional, highly utilitarian EIP 4973. And then Autospace, we are kind of building more flavors or more layers around it. But this, what this had served at the fundamental has been working really good for us so far. And I also actively contribute to the EIP. And it's been super exciting and learning in general. So moving on to the other side of what the topic I wanted to chat about as well, which is definancialization, right? At Autospace, we're the badges, we see this in six areas how we can use a non-transferable token. A membership model, non-financial rewards and recognition, onboarding quests to end with the badge, assess the reputation, more nuanced governance models, and then unlock access permissions of these badge holders. But I want to bring attention to this bit. this bit of that's non-financial rewards and recognition. I mean, I think we can all agree that the ecosystem is like hyper-financialized. And we want to challenge that status quo. Like, if you're in a position of wealth and influence, you can buy tokens, and if your community is basically to design their governance on a one token, one vote system, so a person of influence can basically assert their entire influence through that power. So it's basically plutocracy, right? So we want to challenge that, and we want to move more towards the one human, one vote. But for us, we see the one account, one vote as a necessary step to kind of get to one human, one vote. And then this is really fresh off the grill, right? This happened like a few days ago. The Mango markets. The hacker exploited Mango for 100 million. Hacker turns around, offers to return the funds, and he used 32 million of those votes to say yes to his own proposal because he hacked those and then executed that proposal. And I think we can do better than this, right? Like, that's a no-brainer, I feel. But it's really the takeaway that I wanted to kind of have here is let's move away from the one token, one vote system and away from plutocracy. And I think let's explore new forms of governance. I think it is no one-size-fits-all. I think we're in a stage where the ecosystem is growing so fast, and we as builders, we definitely need more instruments at our toolkit. We need to spark debate, apply rigor, get feedback. So I'm glad that I'm kind of like getting a lot of that here in Devcon. So that's a lot. That's it, and that's a DALI author. We don't work, we just create these DALI orders most of the time. My team is surprisingly good at creating DALI orders. You can scan this, it'll give you more information about us. Yeah, that's it.
Thank you, Raul. We have some time left, 3 minutes. Do we have questions? Yes, okay.
Hey, can you elaborate a bit on the the recovery part?
Yeah, absolutely. So one of the things with account recovery, it actually came up pretty actively in the debate. Like, hey, if I have badges in my account, if you have non-transferable tokens, what if I want to rotate my keys? Then how do I do this? And that's one of the criticisms that were pointed at soulbound tokens initially. Quite frankly, I feel this is not a soulbound problem or soulbound token problem. This is an entire protocol Ethereum problem. And I feel like we need to wait until we need to do this better, and then we can absolutely adopt it. But we are looking at two ways of recovery. One is a proactive recovery and a reactive recovery, but we are offloading this to the community in our protocol at least. So it's basically like moving your phone, like if you're porting your number from one phone to the other. So you're actually doing a proactive action. So you have to kind of like prove that you are the owner of this account and the account that you're porting over to. But the way we're thinking about this is you can't transfer these tokens, but you can burn all the tokens as the owner of the current account, and you can get it reissued through the issuing authority, which is generally the communities or DAOs. The other aspect is reactive recovery, which is where like I lost everything. Then, that's a tricky one. You have to establish with your DAO, for example, that, hey, I'm the same person behind this new wallet. Like, you have to reissue it. And one of the models we are looking at there is reissuance, but the community perhaps can revoke those badges. So that's how we're kind of thinking about it.
Thanks.
More questions? We have time for one more question.
Hey, here.
Just quick thing regarding recovery through burning and then reissuing. It would be awesome if there was a way to do that atomically.
Yes,
so that, right. But the other question was, what is the status of the EIP? Is there time to still make breaking changes, or is it already like so widely adopted? And this kind of relates to the stagnation discussion, but I think it's...
Yeah, that's a good question. I should have actually put the stats on it. I mean, people are already using it. We've seen, I don't know, maybe like 150, 300 hits on probably somewhere on GitHub. So we are actively thinking about backward compatibility when we're adding, but the EIP is in review stage at the moment. And now we're kind of talking about expiration as to be baked into a badge, where you can give like a 30-day expiration badge, for example, especially if you're like joining a DAO, you get guest badge, for example. You can do some interesting action. So expiring badge is something we're looking at, but this is one of the forums we're hoping to get feedback on. Where should we park it? Should we get feedback or invest in extensions? And because there's a lot of utility this can deliver in its current form, and then it would be strange to perhaps stretch this timeline, because I think I've seen EIPs go for years.
Thank you, Raul. Applause, please. Thank you. I'm just gonna, while the next speaker, Sweetman, is going to set up the laptop and so on, I'm just gonna walk you through the rest of our timetable, which is, by the way, here. So next up is Sweetman.eth, and he's gonna talk about the music NFT engineer. Then we have Andres, who's going to talk about the Web3 music NFT multiplayer problems. I'm very excited about that. I think it's it comes out of water and music research. Then we have Ian, who is going to talk about rich content types in NFTs. And then finally, we have Francisco, who is going to talk about a very recent EIP called 5267, I think it defines the domain separator of EIP 712. So if you're familiar with that, I guess it's you kind of understand what it is. If not, then I recommend going to eips.ethereum.org and reading up on it. Just. So give a warm welcome to Sweetman. Thank you.
Hi. Testing. First, quick question. Can I get audio out of my HDMI too? Yes or no? Thumbs up, thumbs down. Yes, no? See?
Test. So while we are setting this up, I'm just gonna talk. Okay.
¿Y audio funciona? ¿Puedo buscar? Okay, bueno. Got a little background music. I'll keep going just so that it's not just me up here talking. No. Okay. Audio is only going to come out of my computer, so we won't be playing that. But I do have a lot of music NFTs for y'all today. So first, I'll ask a couple questions. Who has a music NFT? Okay. Who owns any NFTs on Optimism? Who owns NFTs on Arbitrum? Who owns NFTs on Polygon? My goal is by the end of this, you will have your hand up for all of those. Hi, I'm Sweetman.eth, aka the Music NFT Engineer, and today we're going to talk about music metadata. First, the problem. You're going to see QR codes throughout this. The ones on that side are from musicians in Latin America. If you want to support creators here in Latin America, Scan that, buy the NFT, support local creators. On this side, you'll see CC0 music NFTs, 100% free mint, on different chains. And so they'll be scattered throughout. If you want some NFTs, mint them. The problem, and don't worry, the same QR codes are going to be a little bit hidden in here. Music platforms are not creating music NFTs. This is a very spicy take that I like to hold. You'll see on your left side, these are metadata from the top NFT platforms. Up top, you've got Zora, creator. In the middle, you've got catalog. And down at the bottom, you've got sound. You'll notice that they each have different metadata, but honestly, there's no real differentiation between the metadata of a music NFT and a normal NFT in most cases. Over here on this side, you'll see the music metadata standard. This includes the same attributes as a normal NFT, in addition to attributes that matter for music. Attributes like lossless audio, attributes like BPM, attributes like duration. These are things that matter when we're talking about platforms like Spotify or Zora wanting to index these NFTs and to be able to differentiate between a music NFT and a normal NFT. Why does this matter? When we talk about Ethereum, congrats, we're in the Ethereum Wizards room. We have merged. And so now the next kind of goal in our identity crisis as a community is, how do we get global adoption? I see music NFTs as the Trojan horse for Ethereum adoption. While a lot of people don't care about NFTs, most people do care about music. And so if we can build platforms that allow music NFTs to plug seamlessly into the existing infrastructure, we can allow for more and more people to be consuming the Ethereum technology that we know and love. But the big challenge right now is that musicians are using these platforms that don't really differentiate metadata between normal NFTs and music NFTs. Next, the opportunity. Another set of NFTs. Oh yeah, the last one. I'm sorry, I didn't shout out the creator. So the last creator, this first NFT is Caspiel. We've got Colombo in the audience, manager of Caspiel. And so that NFT is from a musician named Caspiel, who dropped on Zora Creator. And that is a music video of her latest music video, Reflejo. And all of my music NFTs are CC0 from a musician named Sagrado, based out of Mexico. My favorite, because he does everything CC0. This next one, over here we've got another Zora NFT. I think we've got Tranky in the audience, who helped a Buenos Aires creator named, created a platform called Unun. And so if you scan this, it'll take you over to Unun to mint some music NFTs from local Buenos Aires creators. And this one is another one from Sagrado, and this one, I believe, is on Polygon. Last one was Optimism, this one's on Polygon. The opportunity. We have an opportunity right now to standardize music metadata. Right now, it's been in discussions. You might have heard about Telegram groups. You might have heard about different chats that are scattered amongst the music NFT ecosystems. Maybe you've talked with Hi-Fi Labs about their music NFT standards. Maybe you've talked with Zora. There's a lot of different standards out there. We have not really reached consensus, and I find that awesome because there's no gatekeeper. There's nobody that's telling us this is how it is. It's very much a bottom-up. What does each creator want to use when they're making their music NFTs? And again, the full music metadata standard over there on this other side. How you can help. Again, the music metadata standard is not something that we're going to have Sony or Warner or some record label is going to come down and say this is how it is. It's going to be bottom up from the engineers that are building, from the creators that are choosing what platforms to build on. Each of us as individuals is choosing which memes we want to propagate in order to make the best metadata win. The final set of NFTs we've got, this is a catalog NFT from a creator named Hey Bella, who is also based here in Colombia, in Medellin. And this one is an Arbitrum NFT, the same NFT by Sagrado. Spread the memes. All the Ethereum wizards, all of you builders, we are building. It's important that we propagate proper music metadata when we're building. If we're giving these musicians poor metadata, we're setting them up for failure in the long term. As Spotify, as iTunes, as these other big platforms, the Future Tapes, the Spin Amps, are indexing music NFTs, if we're not putting beats per minute, if we're not putting keys, if we're not putting the credits on chain, we're missing out. And so what I've been working on is I cloned the Zora metadata render, which is an architecture that allows us to decouple the ERC721, the ERC1155, all the tokens we know and love from the metadata that they represent. And so we have a full music metadata standard that's fully on-chain, deployed on Ethereum mainnet, Polygon mainnet, Optimism mainnet, Arbitrum mainnet, as well as testnets for all those chains. It's live, the contracts are verified, it's fully running on a platform that I built called Decent. And so what I'd like to ask the community here, I'm not very familiar with EIPs, I'm not really familiar with what we do as a community the formal way, I'm really used to building with the musicians on the ground. I don't know if we need an EIP for like proper music metadata for us to get aligned. I don't know if we just need to talk with the Zoras to properly plug in the music metadata renderer into the Zora stack so that musicians can use it. Maybe it's just me writing an EIP with Hi-Fi Labs and getting it plugged in there. There's a lot of different ways we can propagate this meme out into the ecosystem. I don't really know what to do, and I'm not going to claim that I'm like the king of all this. I just would like to have the conversation more. And so I'd like to ask for help in propagating these music metadata memes so that we can help musicians adopt this technology so that musicians can start leveraging these Web3 rails that make us and the technology that we love so powerful and groundbreaking and like fundamentally changing the world that we know and love. That's it. Viva la música. These are all the music NFTs that I showed throughout. And then these are a lot of musicians that are based in Argentina and Buenos Aires in Argentina as well as Colombia that I work with on a regular basis. And so if you want to talk to some musicians that are based here in Latin America and you want to like get their thoughts or help them out or talk to them about the music NFTs that they're making, I've attached all their Twitter handles above. So please reach out to them. They're the people that are on the ground doing this. I am just some random engineer that's up here talking to y'all. So with that, we've still got 10 minutes, so I kind of zoomed through that. I will leave the rest of the time open to any questions from the community.
Thank you, Sweetman. Hand of applause. So, do we have any questions in the audience? Raise your hand if you have any questions. Yes.
Hi. I was wondering, like, what was your process in navigating to the EIP? Like, how did you gather information about, like, music metadata is a very complex structure, right? Like, and there's not having consensus over metadata just sounds like a classic music industry, to be honest. So I was wondering, like, how was your process to getting to this stage and the EIP generally?
To be clear, there is no EIP right now. This is a bunch of blank data. I copied EIP. I took a screenshot of EIP 721 and I blanked out the data to just kind of like put the meme in your head as something that we can do. I don't question back to you. Do you think this is something we could do with an EIP, or does this feel like you say like the music industry is too decentralized for us to come up with an EIP for a music metadata standard?
I think yes. There is one part that's probably up for like off-chain versus on-chain. I think if you have that perimeter very clearly, I think this is exciting. Yeah.
In an attribute I didn't talk about, all of these decent NFTs, 100% of the metadata is on-chain. So one of the awesome parts about L2s is it's incredibly cheap to store all metadata on-chain. And so we can store that entire music metadata on-chain for less than a penny. And so musicians that are based in Latin America cannot afford to do transactions on ETH mainnet. But by offering them these rails to be able to create music metadata, we can also offer them the opportunity to put it fully on-chain so that there's no trust needed in APIs like what Sound uses, or even like the delay you get by uploading to IPFS if you're not using a dedicated gateway. When you store it all on-chain, you get that instant availability that you get on Optimism, Arbitrum, Polygon, and the other L2s.
Thank you. Do we have more time for questions if there are? Yes.
It wasn't clear. Do you want to write an EIP for this, or do you not want to do it?
I'm very open to it. I'm here in the community. My entire life is music NFTs,
Yeah.
and so if the community decides that we want an EIP, I'm about it. I'm very much of the belief that I don't want to say like this is the way. I like hearing like the music metadata standard. I didn't come up with that. That came out of catalog, and I'm just propagating that meme because it's, in my opinion, the best meme.
Yeah.
If you,
So, no, I think a great first step would be to like, it seems you've done a lot of research to publish that in some written form, maybe in the Ethereum Magicians forum, to just kind of make it visible, and someone else can then maybe pick it up and formalize it in their EIP. That would be very valuable. And I want to offer a counter. I don't think that you specifying something and standardizing something would be like imposing your view of things on the world. It's just offering an option, right? And whether that's adopted or not depends on the rest, like you have said. But having an option that is there and specified and like standardized is extremely powerful, and I don't think it's imposing anything in any way.
Thank you. Do you want to take more questions? We have more time.
Love to, especially if it's from Dan.
Hey, it's quite funny because obviously I wrote the Water Music report yesterday. They came out on this subject. Have you not read it yet?
I have not.
Interesting, because there's definitely points of conflict between how we're seeing this. And for me, having worked like Rahul has inside the beast, as it were, one of the biggest issues in the music industry comes around multi-party consensus around data points and also conflicts. And that's always been my hesitance about putting everything on chain, because it makes things much more complicated and it also creates friction around how much you can actually trust something versus if it's housed somewhere else in some kind of on-chain registry that can be updated by multi-parties. And so that's why my feeling on this has always been that music NFT data should be minimally viable, and contextual rich data should be kept elsewhere, but in a fair way, if that makes sense. So just interesting what you think about that.
What are your thoughts on the metadata render architecture that Zora's put out, where the creator is able to, there's a trusted party, a role that is able to go back in and update that metadata when they choose? Does that make a difference, or you still think the best solution is fully off-chain?
Well, who decides who the trusted party is?
The creator.
But what if there's multiple creators?
I'm excited to hear Columbo's talk on that.
Yeah. This is the challenge, right? And then you've got different rights, you've got writers, publishers, producers, all these people who are part of this rich soup of influence that creates a piece of art. At the moment in music NFTs, we're in a pretty nice place in that it's usually being one person putting something out, but shit gets complicated as soon as that, that expands, right? And I think like it's really important that as we're thinking through this, we need to be thinking for like mass adoption and how to deal with that.
Point well taken.
Nice. If you are taking more questions, we have 2 more minutes. Yes, okay.
Yeah, tranky.
This is more just a comment about whether or not you want to do like an EIP or something. I was in a talk yesterday that was like something called like CAIP. It was kind of over my head, I'm not going to lie. Yep. Like CAP 10, but it was a different type of like improvement proposal sort of like coalition about stuff related to like L2s and things, and addresses. So it could be, they have the GitHub that's like set up. So I think an initial interesting step could just be fork their GitHub and turn it into like a music metadata IP thing. MMIP or something, I don't know. But yeah, just a suggestion.
Yes. So here's the catalog standard, and you're talking about CAP 19 is like cross-chain assets. In here, we have references to other types of assets. And so you'll see in fields like artwork, you have a URI and a MIME type, which is very normal. But then you also have this NFT field, which can link to other NFTs, and that follows the CAP 19 standard of cross-chain. So you can actually link different NFTs. If, like, for example, all the NFTs I just made from Sagrado are derivative NFTs of an original NFT. I did not link the original NFT, and that's a downside on me, and I'm going to publicly say that like I could obviously do better. But the standard is already up to date so that if we want to link other assets within our NFTs, we can. And so when we're thinking about composing NFTs as music that's built on top of stems, or music that's built on top of other music, or a remix that's built on top of music that's built on top of stems, the metadata can link back to those underlying works so that we can always be pointing the credit back to those original users. Did I miss the point of your question? I heard CAP 19 and I wanted to show this.
That is cool, but yeah, I was mainly referring to the structure they have like on GitHub for like organizing community like input. So I think just like forking the GitHub they have would be a great place to start if you were trying to like start the process of figuring out how to like, just like coordinate between a lot of people. Forking their repo seems like a good place to start. Just start housing that information in someplace.
Thank you, Tranky.
Thank you. Yeah, that's it. We don't have more time, so thank you very much, Sweetman. And next up is Andres. And we are staying actually in music. And now we are talking about the Web3 music multiplayer problems, and I'm very excited about that talk as well. Yeah, exactly. Take a water, and you use also the Wi-Fi if you need it. Can we get the picture of the? We have to do it in front. So I think
I'm not sure how to do.
I think because you are probably mirroring the screen, so you have to move the window to. Wait, go to the settings. Yeah, sorry, I don't see you. Where is your mouse? Can somebody help us? Where do we have to go to displays, right? Yeah, and then mirroring or gather windows.
You have to change the arrangement, I think.
I think if you mirror the screen, then
Maybe you have to close the I think it's stuck now.
Is it done?
There you go.
Yeah, that's why they usually say you need at least 5 minutes before a talk to just figure out the monitors and stuff. So, but we managed. And yeah, here's Andres. Here's your microphone.
Thanks. Not a lot of experience presenting, but here we are. So we started off a few months ago in the Water and Music DAO researching about splits. And we basically got to 3 main conclusions. Some of them are very obvious, some probably not that much. One is that blockchains can serve as a login, as a log of information, and hopefully, look into the future, even like a global jurisdiction notary system with a legal validation. The second one is that blockchains have the blockchain architecture is based on a singular point of connection or entry for the user. And the third one is that splits protocols, as we understand them in blockchain, are focused on distribution of funds, but us creators think about splits more on. So what is the problem? The problem is copyright, right? We all know it's the problem and it is the solution. And copyright law has been used and has been abused, but it's still the only or the most widely used form of monetization of intellectual property, right? And if we're looking to the future, where each time we have less and less jobs available, we have a growing creator class, we need to keep copyright as one of those essential ways of monetization for creators. And the copyright industry is plagued with problems, but to narrow them down, it is mainly a human problem, like it always is. And it is that people do not register their intellectual property as close to the moment of genesis as possible, which is actually the best way to protect intellectual property. And and this is maybe because creators think that registering or that speaking about legal aspects in the moment of creation kills the vibe. So that actually gives birth to a lot of problems. I've had problems with processes in which I have been in the studio. I'm a music producer, so I have been in the studio. We've made a hit song. Everybody is super excited, right? The process, as it is done, it is that at least in music, creators get together in a studio and they songwrite, they beat make, they record, and then they bounce off the audio program, which is a WAV file or an MP3, and then that MP3 gets shared among the co-creators, and it's either emailed to us or it's WhatsApped, and we can listen to the music or what we made and vibe to it, and hopefully the next day know if what we did was whack or if it's a hit record, right? So personally, I have been in those situations, and I have been muscled out or cut out of hit records because the more savvy people will head out and register the copyright of the song. And this is a story that kind of like repeats itself endlessly in music making. So what would the ideal process be? The ideal process would be to register, to have a mechanism to register the IP as soon as possible, right? In a nutshell, it would protect the creators and hopefully in consensus be able to register this IP in consensus, right? So we have a solution, right? We have temporarily called it a copyright wallet. And a copyright wallet it's a tool. Basically, it's a tool that is inserted in the job to be done. It's like a small, sharp tool that is inserted in the job to be done process, and it allows for, in multiplayer mode, deploying a registry, timestamping a registry on the blockchain of that intellectual property. So this is design coming from a musician, right? But in essence, what it is an application, an extension app that would register the title of the song, let's say in this case, the ownership splits of the participants, and a mechanism to drag and drop the media. The same way a chat would, have access to listening to a voicemail or a shared audio, the mobile wallets of the participants would receive that audio, and they will receive a notification to accept or deny their participation in that creative process. And if there is consensus, then a smart contract is deployed, and the non-transferable NFT is minted as registry. So, and before we go to future iterations, I would like to, obviously, I think this is time better spent if we open up a discussions, because, I mean, this could be a tool that obviously expand and is composed on, but I would like to basically just open the floor to questions to see if we can get to a technical solution, because the questions that we have is, and the main question we have is, does this really need to be a wallet, or can it be built in a simpler way?
So thank you, Andres. Do we have questions, feedback? Raise your hand, please. Yes, I see you.
Thanks. Maybe we could go back to the previous slide. I just had a question about like what you're saying in ownership splits, and it's kind of related to what you were saying, where like ownership splits are more than just like who's getting what percentage of like mint revenue or something like that. It's much more. So when you're in that top left corner, when you say ownership splits, are you already like envisioning this like breaking down into like mechanical and like publishing royalties, or are you trying to not necessarily be skeuomorphic and instead do other types of ownership splits, or what's the idea here? I guess a greater question that just how much of the current music industry are we trying to recreate on chain versus maybe moving to stuff that's better in some way? Not that I even know what's better, but yeah.
Yeah, that's a good question, and the answer would be either one of two answers. I'm guessing the dynamics, the current dynamics are more of like you songwrite and you fixate on a recording immediately, right? Just because the tools are available, so people are not writing songs with their guitar, but they just they just record them immediately, and that is just because we have the tools to do it. Unlike before, we used to like write sheet music or write song lyrics on paper. But I guess the answer to that would be we could either do two registries or just split percentages, because at the same time, like writing and mastering is basically recording is like a 50-50 endeavor, right? So we could split from just one big chunk of 100% of ownership, or mint, specifics.
Any more feedback? We have more time. Yes.
So is the biggest reason we want it to be a wallet so that we can have that kind of signature-based approval, like the question from Dan in the last talk of deciding when the metadata would get to be updated, or if a piece of work can be included into a movie, or if the rights could be included, like you have that signature step from each of the participants? Is that the reason, kind of thinking of it as a wallet, or what's the reason to have a wallet be the mechanism for controlling the rights?
So that is one reason. And the other reason is, and this is very personal, like looking into the future, what I think that would happen, or would happen, or would make sense if it would happen, is that this contract is like the master contract of all the IP that is derivative from this original registry. So from this original registry, and we spoke about it briefly on Twitter, we could also have some form of progress NFTs where everybody is, for example, we go into the studio and then somebody's going to come and feature on a song, right? That he was not, or she was not in the studio on the first day of the recording. Then there's a way of tracking the progress of the intellectual property. Obviously, you could go like even deeper with content ID mechanisms and whatnot. But I think that this smart contract would probably evolve to be like the master contract, where you would mint the one of the song, or the 10 editions of the video, and all the derivative works, and accrue all the value in one contract, basically.
Hey, something I'm really interested in is using time as a constraint to force kind of consensus between a group. And this feels like it could be quite that could be quite an interesting thing to bring into this. I actually wrote something about this in like February or something, about making multi-sig wallets in a similar sort of way. But when I did that design, I proposed that you have like a time period that can be defined in which data can change, and then at that point it's finalized and boom, it goes, and that's that. How do you feel about that in terms of like this workflow? Like, do you see that you've got multiple parties kind of putting their information in? Do you think that should be locked down at a certain point, or how are you thinking about time as a concept within this kind of formalization?
I think the ideal scenario is that creatives agree on percentages of ownership immediately. I wish, right? Yeah. We wish. But if the tool is available, that might be an incentive, right? And if we fulfill the promise of value through these specific type of creative products, then we might be able to take it a step further. Because, you know, like 20 years ago, splits were non-existent. Basically, publishers and record labels were the ones actually doing the paperwork. But it has evolved in the creative mind that they own their creations and that they want to be a part of splits. So more and more you see like producers and artists and songwriters be like, okay, like let's show me the splits, right? Or let's negotiate the splits, hopefully as soon as possible. And this is kind of just like inserting it in that moment of you bounce the song, you share it. Is there consensus? How are we, you know, like splitting the ownership of this? Let's log it on the blockchain, and it should serve as a proof of work in case there's like legal challenges on the process.
Yeah, I have a question. So I understand this. My mind tries to abstract this like the concept of self-sovereignty in intellectual property, but then I see this like conflict between the existing structures and the structures, the social structures basically, and standards that would have to evolve if this were to actually come and have any chance at becoming like the dominant form of you know, managing creative IP. I'm wondering how you see like the end game of this playing out. How can this actually win out over the structures that we have right now, which are very strong power structures?
Well, the grand idea would be to finally have a global copyright database, right? If that makes sense. It has been tried several times. I know a lot of people are accepted to that, or I don't know if it even is a good idea. But there has been efforts in, you know, like just sharing the information, but the power struggle between corporation makes it impossible, right? They don't want to just have that be one entity, and that's where the efforts have died. Is it good or is it bad? I don't know. I mean, probably haven't thought about the consequences, but just transparency on data, I think should be publicly available and should be, you know, like just like a public good. Huh?
Last question.
Thank you. Are these splits renegotiable at a certain period after a set time? What does that look like? What's the current kind of discourse regarding that?
Yes, so copyright law actually states that your right on an idea is immutable. Nobody can take that away from you. So Hypnosis can buy the Bruce Springsteen catalog, but, you know, like Merck could never say he sang those songs, right? Even though he owns the financial exploitation of the IP. So, and that's like maybe a stupid example, but having the possibility of making like having the immutable record of you were there, even though you might see the financial retribution of that IP, you have the right to be credited as the author.
Thank you, Andre. Thank you for the talk. I think I really liked what you. There was like this one quote that you said, like copyright is immutable. That is definitely something I think we can probably all take home and think about for a while. Next up is Ian, and Ian is going to talk about rich content types in NFTs. And yeah, if you are new here, basically what we are doing is the ERC Lightning Talks. We are the ETH magicians, and we are talking about Ethereum requests for commons proposals. So not the core dev consensus layer stuff, but the Solidity interfaces, application, like these standards. Yeah. You have Wi-Fi, you have water if you need. Thank you. Warm applause for Ian.
Thanks for having me, Tim. It was wild. We met at ETH Berlin a while back, and to see you back in the space. Yeah. I'm going to give a quick talk on canonical media and EIP content type. So the notes are basically, I'm just going to flip through JSON and talk about it. The notes in JSON are on GitHub. If you have questions beyond the talk or you're watching it recorded, make a GitHub issue. Probably the easiest way to respond. And I'm just going to open a conversation about kind of what we've done previously as an organization at Zora, what I've done personally for certain NFT projects, and rendering. So if you go to the original EIP 721, the metadata schema is pretty lightweight. You have a name, description, and image. It was designed in the era of CryptoPunks, CryptoKitties, where you tracked ownership, and the image just kind of showed a cute item or like the thing, and then that became more and more important with time. I think it was left pretty open-ended for people to build out from here, and I do like that idea of a very minimal standard, and then people can run with it, but I think at some point that standard can also be improved. So an example is, and I've had coworkers ask me this all the time, most recently somebody asked, how do I mint a presentation? And the easiest thing to do would be to export your Keynote or Figma as a PDF and then mint it, right? Well, unfortunately, the metadata standard just says image. So what people have done, OpenSea kind of added animation URL to show an animation, which could be a web page, GLTF, audio, a bunch of random grab bag of content. And the great part about an image is if you want to render it as a consumer, you just pop it into an HTML image tag or you put an image viewer. Images are pretty well defined on how to render. Animations get a lot more complex. What we could do is we could convert the presentation into an HTML viewer and upload the HTML viewer. That becomes pretty cumbersome and a little bit difficult because the original content is a PDF. It's not the HTML viewer. And the way Zora approached this with the Zora protocol in 2020 that I didn't really work on, that was before my time, was to separate this concept of metadata and content. Content was one thing, metadata was another. And the idea here is that the NFT represents you own a particular ID, and that particular ID represents a canonical off-chain content. Zora highly recommended to use IPFS, which is decentralized distribution layer, but as a future-proofing, also used a hash function, SHA-256, which fits really well into a standard Solidity data type. The Zora Core v0 Solidity has a function for the token URI, which is not the metadata as the standard defines. It breaks the standard, but is actually the canonical content. So if we were to mint a presentation, it would be the PDF. And then the metadata is defined also incredibly simply as name, description, MIME type, and version. The MIME type is useful for rendering. As I said, you need to have some idea of what you're going to render before, and fetching it from the server just to figure out what the MIME type is a little bit frustrating. So this here calls the token URI. It returns a IPFS file. And then here, that file is just text of these two icons. The token metadata URI is name, description, MIME type, text plain. So that tells the Zora platform to render a text plain image of that text plain of that NFT. And I don't think there have been a lot of platforms that support this. So when you try to look at it on OpenSea, good luck. And that brings me to my next point of thinking about going back in computing history of what people have done to solve this problem. This is a multi-part form data. It's used for email, kind of, and used when you upload files in a classic web form. It has content type, and it has a certain set of attachments. You can kind of think of this as an email attachment. So I think having content type is quite important. Content length, maybe. We can talk about that a little bit later. And then the body of that exact content. Here you have an example. Sorry, got out of the way. So an example of what we could do is add a new field to the metadata standard, either through a secondary proposal mechanism or the EIP standard that represents what we just talked about. And there's a lot of details here to unpack. So one of them is maybe you'll want to include the content directly. Should it be body or should it be encoded in the data URI? In that case, the content type is redundant. But when you have an external pinned file, you really want that content type for rendering. It just makes life so much easier from a platform and indexing standpoint. If you have a really obscure file type, let's say somebody loves to upload Illustrator files, you could use an indexer to find every Illustrator file with a very simple content standard. And I think the idea here is you have a token ID represented by a file, and the metadata describes what that file is, but that file, when you need to have a file with your NFT, is the highest resolution, the most well-known version of that. An example is Zora was brought on to work with the Warhol Foundation to mint one of the original computer NFTs, and it was made on an Amiga with a beta version of software. And art collectors were really frustrated that the NFT was a TIFF file, but it was built with the Zora protocol, meaning it did support TIFF files. However, nobody else did. So what we had to end up doing is use the external URL, which is an OpenSea extension, to link to something, to link to the TIFF, and then switch the image URI to become a PNG that renders everywhere. And this is after back and forth with conservationists and with different protocols as to what they expect the NFT to be. Now, if we were to use the content standard, we could define the image that renders as a preview with IPFS, and then we could use the Amiga MIME type, or just a binary blob with some notes around it in the description to refer to the original media. And I think that would help conservationists feel better that the NFT is representing what it really represents and not needed to be converted into a new format to be an NFT. And a second example of this is Mirror. So if you were to mint a Mirror marketplace essay, this is what it shows. It just shows a cover image of the text of the title, a description, which is a link to Mirror, and that's it. I think there might be like the author information in the properties. But it would be really cool if Quixotic has a relationship with Mirror and they could download the canonical markdown file and start rendering it on their site. Or at least say, hey, there's a canonical markdown file associated with this. And like GitHub, it would just open a markdown viewer if it understood it. And we can take a look at the JSON here. So if Mirror currently what they have is they have a content field. And it goes to an RW file, which is a custom content type they defined. It's quite rich, has a lot of information, but it has the body, the author information, signature information, and stuff they use to run their platform. The problem is if we're coming at this from a perspective of an indexer, this is not very helpful. We could try to expand that content field, but that could be any file type, as I said before. It could be some binary blob, or it actually could be useful JSON. So if it's defined as JSON, or maybe an extension to JSON, you could use that. But the idea here is it would be the markdown. And if Mirror has extra information, they could use their own fields to refer to that information within the content file or outside. There's a way you can actually add JSON headers to markdown files. So, you know, the file itself as an abstraction is really powerful in this case. But if you were to rewrite this using content, you could use text markdown, and then Quixotic could easily parse that, not just from Mirror, but from Zora tools if somebody were to mint a markdown file. And this has happened before when Matthew Ball wanted to mint his original metaverse essay on Zora. But we wanted compatibility with more marketplaces, and we wanted parts of the metadata to be fully on-chain. The Solidity contract renders the metadata JSON on-chain, but it links to an HTML file of the markdown content because that's what animation URL supports. So we're having to change the media type into something that fits within an NFT. An easy way to avoid that, and also, if you look at it on OpenSea, it doesn't properly parse an animation URI with an IPFS:// right now, but you can see the metadata is getting loaded in. But the essay experience, being a tiny box, is really frustrating, and links don't work for security reasons. Here it's slightly better, but also links don't work due to security reasons. The sandboxing on an iframe is actually pretty difficult to work with. If this were a markdown file, you could just run it through whatever markdown renderer, or even provide a link and just show the preview image associated with the NFT. A final example of this is the Dead Ringers. It is a part of the Ringers Art Blocks collection, and it is a follow-up limited time edition where funds went to charity, and it was a very large SVG, megabytes and megabytes SVG. And I believe Manifold helped with the mint. And the original file for image was an SVG. But that SVG broke wallets, and people were not happy because an SVG is text, and for you to encode text, you actually have to turn the SVG into some sort of bitmap format and then convert it again and resize it. So it's really difficult to resize an SVG, and most marketplaces pass through the SVG, but this particular SVG was so large it started breaking stuff. So what they had to do is they actually had to update that and change the image to a PNG that did render well, but it was a 21,000 by 43,000 pixel PNG, which also caused some problems. Because marketplaces take in the PNG or whatever image file, resize it to a reasonable size, and display it. So what we could do now with this particular proposed standard would be to include the optimized image that renders well within marketplaces, and then have the canonical content be the super high resolution file the artist intended. So if you own that NFT or wish to display it, you can then download that original file and work with it as you will. And if you were to take the content type, you could then encode the image SVG XML and then a URI, and then optionally include a SHA-256. If you were using Airweave, that's actually a really nice way of verifying that the file is what it is, because Airweave doesn't use content addressable hash. So the link to IPFS for every file is unique per file, but for Airweave it's different. So the idea here is the SHA-256 is a really standard way for a very long time of verifying that a file matches a file and can be included in this. So overall, the idea of this proposal is to add in a content field. And the idea with content is it's quite simple. It doesn't have any underscores. And it's the first time I think there's going to be some proposal or thought process around creating nested structures in the metadata. But I think it's quite useful because content underscore type content, it just doesn't, like we already have JSON, we can nest this. But type URI, SHA-256, and potentially body for those that want to directly put plain text in. But I feel like URI encoding is also usually a fine option. And I'd love to hear what different creators of standards or media have. Another thought was you could have some sort of attachments associated. Say you have an image, that a product you're selling as an NFT, and you have a slideshow. I recently worked with the team to show a product, and the slideshow had 5 images. You could theoretically include those as attachments in your and then that would be rendered as like a generic attachment on media. I think that's a little out of the scope for this project, though, and I would like to kind of focus on this idea of a single canonical file instead of a set of files, because it makes sense to have a single file and a single NFT ID relate to each other, and to not really focus on banners and colors and multiple sizes, kind of on the side of Open Graph, where you have this media, how do you render it well on a marketplace or in another context? I think that's out of scope for this particular focus. And the meaning of canonical is to have a standard or primary authoritative body on a subject. So the URL is the authoritative idea of what that NFT is, and it's left up to interpretation of the creator or the platform to figure out how to best express that and use it. My open questions are, should this be an EIP? Within the Ethereum Magicians group chat, that's a pretty widely debated topic of metadata is included in the original proposal, but it's not really defined beyond that, and it's defined quite loosely. So one thing I like to do is try to stick to proposals, and I'll typically use the key properties instead of whatever has been defined otherwise, because it's in the 1155 spec, but I am mixing the 1155 spec with the 721 spec. And then multiple files, just an open question. So I'm going to wrap up. If you're interested in asking questions from the recording or want to continue the discussion, I have a GitHub of these files, and this is my Twitter. I can zoom in a little bit. And then the one last thing is there was an on-chain version of this EIP content type that used MIME content URI and hash, and this is kind of the inspiration for the off-chain version of this proposal. On-chain, the idea is if you have dynamically generated SVG, it's more composable, it's easier just to return a struct. But I think now kind of working on more projects and kind of finding more examples, the off-chain example is more compelling, and you can still generate a JSON blob on chain, including the content field. So it kind of works both ways. I just think this is a better start to the approach, way to approach this project than including a new getter function as an EIP within the Solidity world. This is all off-chain metadata we're talking about. I have a little bit of time, so be glad to open it up for questions.
Yes. Thank you, Ian. Thank you. A round of applause. We have one question.
Hi, I'm Marcus. Nice to meet you. If this was implemented as an EIP, what do you think the second and third order effects of this would be?
I hope the very first thing is indexers. Platforms would include it in minting. So Manifold actually does really try hard to include a lot of metadata. They do image underscore URL. Image includes the hash and the URL and the content type and some other data. So I think kind of syncing with them to figure out what their needs are. But once you start having stuff minted in this format, I think it's going to hit indexers. And then once indexers can understand this, people can say, oh, I can upload Illustrator files. I can upload WebGL shaders. I can upload some binary form. Like, you can actually now mint a Solidity contract. And when somebody buys it, they'll feel more assured that they're actually buying a Solidity contract rather than somebody or the file of a Solidity contract rather than somebody saying, oh, here is a Solidity contract. And what I typically have advised creators to do is actually explain it and link in the description the IPFS URL of the canonical media. It's hacky, but it seems to have worked. And that would kind of remove that and allow for users to see like a link. And I've seen artists on Twitter talking about using unlockable media in OpenSea to include the source files. And if the artist is comfortable, they could just include the source files and it would be a link or some sort of description on marketplaces. And since this is relatively easy to implement, once a few start, I think it would start spreading. Yeah.
Thank you. We have another one here.
Thank you. Hi, hello. Congrats for the project. So content type is a response header on HTTP, right? Thinking about, the second order effects, have you thought or worked on the request headers equivalent, like the accept, and then having some specific wildcards, such as text, / and then wildcard?
So the one problem when you're indexing is that a lot of times IPFS is really slow. People's servers go down. If you're able to get the metadata on the client, a lot of people hot link directly to an IPFS gateway. And pulling the content type out of the headers really allows for a better set of expectations when you're indexing and rendering the NFT. But your question is to kind of use the HTTP response conversation to define the MIME type rather than put it in the metadata?
Yeah, sure. So there's the content negotiation step, right? So and then you have from the accept request header, and more often you have like some sort of wildcard there.
Right.
So that can help more generic applications to accept, let's say, image / column / wildcard. Something.
So I think a lot of the off-chain NFTs go through a decentralized gateway provider, and those gateway providers are not very, like, you're out, the control of the server retrieving decentralized media is out of the control of the user in most cases, so you can't rely on a server negotiation. You're thinking of a world maybe where there's a server that is connected to the URI of the NFT, and that's becoming a lot less common because that means you're now having a centralized point of failure. So the idea here is if you put it in the JSON, there'll at least be some intentionality. If you're on some weird version of IPFS like node that doesn't understand the media it's serving or there's a bug in it, you'll still have something that kind of works or have an expectation of what the original intention was.
Thank you. Do we have more questions? Maybe one last question? Okay, otherwise... yes, okay. We have one.
Here you define the content type inside the JSON to like save some uploads. Could you define the data in the collection as well?
That's actually a great question that I didn't have time to address, but Mirror and Zora and a few other platforms have additions. And I think utilizing a singular NFT metadata in the contract URI, which is an OpenSea extension, is a really effective way to handle that. And right now, I know most platforms that do additions support the contract URI. So for Dead Ringers and for Zora additions, the contract URI is actually generated on chain, and sometimes we'll put in IPFS depending on how big the content is. And that includes image and includes animation if every single thing in the collection is the same. And we use that internally in our infrastructure to give a preview if there's no mints yet, or like what that whole collection is supposed to be. There's no standard around it, but this would also slot quite well within the contract metadata. If you wanted to have a canonical contract content field, it should just work.
Thank you, Ian. Round of applause. Thank you very much.
Thank you, everybody.
Next up is Francisco from OpenSea, thank you, which is going to speak about EIP 5267. And I have been saying the entire time that it's about the domain separator. So, yeah, okay, gladly. Yeah, I just... So yeah, round of applause for Francisco.
Hi. Yeah, so sorry, we're going to move on from NFTs now. It's going to be about ERC20s, which are boring now, but okay. Correction, I'm not from OpenSea. I work at OpenZeppelin, maintain and develop OpenZeppelin contracts, which obviously maintains many ERC implementations, and so this is a really important topic to me. So this EIP that I'm going to be talking about is really quite tiny, but I want to use it more as an excuse maybe to talk about the process of building an EIP and what the kind of steps that I think one should follow. So, because like EIP 1, which it's not here, but maybe you've all seen it, kind of defines the series of stages like draft, review, last call, and final, but it doesn't really say what should happen in each of those stages. So I want to share how I personally am thinking about that as I develop an EIP. Yeah. So the problem at hand here is the ERC20 permits. Anyone that has used a AMM, a decentralized exchange before, knows that in order to do a token exchange, you need to approve first and then transfer. And this EIP permit is one way of foregoing the initial approved transaction and replacing it with a signature that allows you to do it all in just one transaction by just including the signature in the first transaction. So this saves gas. It is one less transactions and it uses the signature instead. But it's kind of weird if you use an exchange or an aggregator. You don't really see this being used very often. I think maybe just for like USDC exchanges support it, but there are many other tokens that have this and don't. So a question that was in the back of my mind is like, why is this? Why is that so weird? So this EIP underneath uses this other EIP, 712, which is a special kind of signature. It's a signature not of a blob, which is what we see often, most usually, but of a kind of typed data structure. So it's kind of important because it allows you to get more structure to it. In the case of permit, you will include the amount that you're allowing. You will include an expires, timestamp, and a nonce, and so on. And this is an important standard because wallets can implement support for it and show this structured data to the user in a nice way. One of the important things in this EIP is the notion of a domains. So when you make an approval for, say, USDC, you don't want an attacker to take that signature and kind of send it to DAI, right? You don't want an attacker to reuse the signature in a different domain. So every signature has this domain separator inside of it that makes sure that the signature is only valid in one domain. So this is the right. So the decentralized exchange has no way of knowing, given some arbitrary token, what domain they want to use. And I think that is the reason why this hasn't been really adopted. So you will see that the ERC20 permit ERC defines a getter that gives you the hash, but really the 712 RPC endpoint requires the entire domain object, and there is really no way to find it here. So this is where EIP 5267 comes in. Now, we will see now it's a very simple function that literally just allows you to obtain the domain. This is the domain object that you will need to pass into the 712 sign RPC call. And as you can see, like, it's extremely simple. Now, what was also in the back of my mind is that this is not also a failure of the spec 2612, so permits, but it was also in a way a failure of the process, because if the 2612 authors had kind of gone all the way and kind of talked to decentralized exchanges and thought through what it would entail to adopt that, they would have realized that this was missing. So I didn't only want to tackle the technical problem here, but also think about how can I carry out the process for this EIP to make sure, and other ERCs, to make sure that this sort of failure of the process doesn't present itself. So the question is, how do we get this now, which is in review stage, how do we get it now to final? What needs to happen in order to get it to final? So some of the things that I've done, and that I would recommend you all do when you build your EIPs. So you should reach out to all interested parties, and like applications and companies and projects that you think will be using this. And really, you should be kind of bothering them to give you feedback, to look at it and give you feedback. So I've reached out to 1inch and Uniswap and kind of seen, try to get from them, is this useful to you? Does this solve a real problem for you? And generally, the answer in this case has been yes. In the Ethereum Magician thread, there's also been a couple of interesting comments on common questions. I have taken some of the questions and documented them as part of the EIP as well, and also some concerns that have arisen. So many of those concerns in the case of this EIP were about the backwards compatibility section, which is here. But most of the discussion of the Ethereum Magicians thread made me realize that even though I wrote this section and kind of thought about it, there really are many more unanswered questions. So I wanted to do some more work to figure out the real backward compatibility story. So another thing that I've started doing, which I think is a really good exercise, is to implement it, and not only like the Solidity part of it, but also the many parts of the stack again. So I've just started this repository with the implementation, and most importantly, a little app, which is just a front-end app, which is what I imagine that a decentralized exchange will kind of be doing behind the scenes. And here I'm putting myself in the shoes of, I am the UI for 1inch, and this is what I'm going to be doing, and just kind of really figuring out if it works, if I can actually produce the signatures that they will need to produce, and also to use this to figure out the backwards compatibility story. And I still need to develop this a little bit further, but I'm hoping that I'm going to come up with a good and kind of comprehensive answer that I can then go back in the EIP and document it there, to make sure that it really answers the concerns that were raised in the Ethereum Magician thread. So I think, yeah, that's it. Again, it was very quick, but these are some of the things that I've been experimenting with in order to get this to a final stage. I think there are, we see many EIPs that take more of a fast track and get to a final stage, which is, you know, it's better in a way, because we know that these processes can be long and it's really annoying. but then you get to a final stage, and it doesn't necessarily mean anything if it hasn't been thoroughly tested. And then you're really going to run into some issues when, say, OpenZeppelin implements it and people start deploying it, and you realize, oh, fuck, this isn't really enough. So then you need to start thinking about like a follow-up EIP, and it's all really much more complicated than it should be if we do things better before we get to a final stage. So anyway, those are some of my ideas. Thank you. Happy to take questions, if any.
Yes, thank you very much. Do we have questions? Yes.
Hey, really cool. First comment, it reminds me of like the Amazon 6-page written narrative way of you have to like sharpen your point or your case, and then you go around and get feedback from people and then incorporate that in a FAQ at the end of the document to like, because you know other people will have those concerns or objections. So that's really awesome. Can you just speak a little bit more about that process and how you followed up with people maybe on this one or something in the past? So it's one thing for somebody to say it looks great, maybe give some feedback on the Ethereum Magicians post, but really an EIP's success or failure is like people using it, like you just spoke to. So do you have a good example of like following back up with protocols and actually getting them to implement the EIP as part of your kind of biz dev work, if you call it?
Yeah, so good question. I haven't thought about that too much yet, but one of the things that I personally struggle with is that I feel like I'm in a bit of a conflict of interest position because of being an OpenZeppelin contracts maintainer. It's like, it's going to be really easy for me to put this in the contracts and make people use it, but I don't want to force it down people. So, for example, one thing that I could do, and now that I'm thinking about it, I think it would be a great idea, is to talk to this one-inch developer that I talked about, and maybe try to get them to walk me through, do they really see themselves implementing this, and maybe what is the timeline, and kind of, just trying to get more concrete data on their plans and try to get them to commit. Maybe that's what I would do.
Thank you. More questions, feedback, maybe people that have used this or 712. Raise your hand if you have a question. Okay. Then thank you very much, Francisco. Round of applause.
Thank you.
Thank you. Yeah, and that's essentially it. That was the ERC Lightning Talks from the Magicians. I hope you all liked it. You can find each and every one, hopefully, on the ETH Magicians forum. And I'm looking forward to all of the posts that are coming out of these discussions. I want to thank you all for participating like so much in this conversation, and I really appreciate that we were having like a back and forth between the audience and the presenters and so on. And yeah, it was great to be able to host this, and yeah, thank you very much and see you around.